All right. Good afternoon, everyone. We are back. And this is MEDIABOXENT on Amazon Live, YouTube, and Facebook.
Welcome.
Multicasting today. We are everywhere.
Oh, you had the microphone.
What?
We can hear you double because you have.
Okay, that's it. I turn it off now. It should be fine there.
Mhm.
And should be fine. It's all fine now. Okay. So another wonderful Saturday here in MEDIABOXENT. What we have on the side, will be my right side. We have the little robot we're going to be building today. You see it right there now.
Oh,
yeah,
yes.
yeah, right there. So I have that one there. But like always, we also built last week a 3-wheel car, and we didn't turn it on. I mean, we finished. Normally, it takes about 2 live streams to complete one project, maybe 2.5. So what's lately happened is we start one project, and it takes like 2 Saturdays, and then the follow Saturday we complete one and then move to the next ones. Always, and I like to recap and show you what we did the previous Saturday. Remember the show that said I know today I'm a little late, but it said 1 o'clock in the afternoon Eastern time every Saturday. We are casting, so it means be able to catch this on Amazon. Right, that's a mainstream right now, and then we cast it through YouTube, also in Facebook as well too. All right, and for those on YouTube, I just put all the links. All right, all the links are available right below, and the link for these live streams if you guys want to join the mainstream here on Amazon, where you can actually see the carousel and all those things. All right, so we're going to look into this. We're going to look in the 3-wheel car, and then at the same time, we're going to be looking what we're going to be build. The other project is a little different than what I built until now. It goes by different. I mean, I have to go not about class, but they break it down in instructions. The instructions are break it down in pieces. So we're going to follow that way. Can they show you, okay, how the Arduino works? Because the next one is it works in Arduino. So how the Arduino works, what we need to do. So I like to follow the way. So it's a PDF. So in the beginning, it's going to be a lot of PDF stuff. We're going to be reading about it, or kind of scan reading a little bit to get into that. The idea is, if you never build any robotics, that will be the way to do it. The idea for that project is, okay, I never work with Arduino. I have no idea what Arduino is. I don't have an idea what a servo is, or a capacitor, or whatever, right? A piece of cable. All right, so the idea is, for that project, it's a beginning type, okay? Can they maybe we move around with this? We went more experienced version, then we went to easy version, like the 3-wheel car. Was kind of easy. The programming thing was a little bit up in there. We had to put some things together. It took a little while for this one. So it depends on the project, and depends why you need to turn it on and turn it off, and depends on some the manufacturer. The company has the different ways to put the structures together. No complaint up to now. I have to say that what companies have been working with this right now, they're about to have the real good PDF format, which is a different way to write instructions. But when you just build few, you kind of get the rhythm on it, and you start, I remember when I did the first one, it was a little more complicated, and as we move along, we go much faster. Also, we have to understand that I go a little slower too, because we're live streaming this, so I have to pay attention to many windows here. The live stream, if somebody talks in Amazon, somebody somebody's on YouTube, on Facebook, so I have to pay attention to that. See, right now, right over here on Facebook, I says hi here to Samantha. All right, and let's put a like there. All right, so we're going to be flowing around today. So these projects, it sets every Saturday. We have more. Later on, we're going to review, and maybe we're going to review a little bit what we're going to be seeing coming up. And I think this project we're going to be building out, I think it's going to take 2 Saturdays. That's what I'm seeing up to now. We're going to review a little bit. I do not go much review into it. I really review like 5 minutes before I start the show. Kind of get skin reading. So some of the stuff will be surprise for me. Kind of that's the way I do it. But we got all the stuff we're going to be building. We're going to be building another big car. We have another little robots and another bigger robot. So we're trying to get more involved to this, to get more projects. And with the Raspberry Pi, Arduino, and beyond that point. So we see what we can build every Saturday. But the idea is, and use STEM. Right, Menina?
Absolutely. We're going to use STEM, which is science, technology, engineering, and math, and it's going to help you learn so much stuff and do everything more productively.
So the idea of this is covered for everyone, no matter how old or how young you are. The idea of this is let's put things together, and I think a Saturday is perfect, fine. Some of this project, if for me, takes 10 hours. Maybe if you just concentrate yourself, maybe it takes a little shorter than that, but it takes about a day. Right, just put it all together and read. The idea is now also go super fast. The idea is enjoy what you're building, because if you're desperate trying to build it, then in reality you're not enjoying anything. But you have to try to understand what you're doing, and at the same time, let's put things together. Some of the things required for this project, some of the kits it will require Raspberry Pi 3, and it's available now at Carousel Raspberry Pi 3. And by the way, the one we have here is good pricing. It should be around $37, and but up to now, it requires Raspberry Pi 3. You can use the 4. So if you have a 4 running around there, an extra one, you don't need it to use for any project, go ahead and put it in. But also you save a little box there. It doesn't require that power. Except if you say, okay, I know exactly all the programming on the Raspberry Pi, and I can do beyond what these things calls for. It maybe requires a lot of power, CPU power. Then you put the Raspberry Pi 4. But 3 is perfect for this type of project with that. Some has batteries, some not, so you need sometimes get the batteries. That is special batteries. It's not a special battery, but easy to get through Amazon. Pretty simple, but they are pretty common batteries that across the board they've been using right now in cameras, skateboards, and anything. They use these batteries everywhere, and they are available on the Carousel as well too. And memory wise, right? We use the scan disk memory. We have in our Carousel a good package of 3, 4, 16, and 16 gigabytes. And we don't need more than that. Can I put 32? Sure, you can put 132, you can put 128 if you want. But I think for this project, 128 is perfect. You don't need more than that. And always remember, if you decide to get another memory, make sure you get a memory is well-known memory. Because what I'm saying, and if you get sometimes some of the memories, it can give you errors. And I went through that already. I went through some of the memories thinking, okay, they are much cheaper. I'm going to buy half a dozen of those, and Raspberry Pi gives me a bunch of problems. So be careful with the memory, because the instant thing. And the next thing is, make sure you got a good power supply to power up your Raspberry Pi 3 in the beginning, because in the beginning, in regards to power up, install the OS and all those things. And if you don't have a good power supply, it can keep a problem. And it happened to me. It almost spends half an hour and figure out why it's crashing, why is all this. That was right in the beginning. And then, so okay, power supply problem, or cable problem. Even I have a better supply now, and sometimes now the cable's giving me problem. So I have a little thunder thing that shows on the side. Not enough power, my friend. So be careful with that. All right, so I guess we did the whole introduction, but let's introduce us here and we go something this way. Guys, how we doing, everyone? My name is Dario from mediaboxentlab. And behind the camera,
Menina Murro, I'm always ready to answer your questions.
Yeah, remember, for those who follow us on Amazon, Menina is every morning, right? With a home tech decoration and much more every morning, Monday to Friday, every morning. And catch up Menina if you want to meet Menina,
Right here at MEDIABOXENT.
Yes, MEDIABOXENT here on Amazon Live. You can catch her in the mornings. Then I will be back. I'm back on every day, Monday to Friday, here on Amazon on MEDIABOXENT. And we start at 5:30 in the afternoon Eastern time. Right, and then we come back on Saturday at 1 o'clock. I know normally Saturdays we've been doing in the morning, early mornings in keto. But today we took a little break. So that's why today I didn't announce the show during the week, because I know I will skip today. So we come back now at 1 o'clock, like always, robotics. Right?
Absolutely.
My next one is why you need to follow MEDIABOXENT no matter what, guys.
Because
chat. I'm sorry. Chat.
We have to chat. You know what? Because we are going to answer your questions. We're always ready here to help you.
Yeah, chat that. I just mixed up the line. And the next one is you need to follow MEDIABOXENT no matter what. Facebook, YouTube, or Amazon.
Because we have a whole bunch of open boxes or exclusive coupon codes, and you're going to be able to see so many products in detail. Yeah, so make sure you follow that, because we got a bunch of stuff here on Amazon. Great coupon codes all the time. Okay, we're all in. That's it. That's the whole introduction. Let's concentrate what we're going to do now. All right, so the idea now, and let's go up and show you guys. So last week we completed this one. Took one day, right? So this one we did finish in one day, almost like 6-7 hour live stream.
maybe a little less, counting instructions, breaks, and all those things. So let me show you what we did, and we're gonna turn it on. It's pretty cool. You can control this with the Wi-Fi. You can control this with the PC, and also as well with the app. Just gotta refresh a little bit how to run this. Oh, through the web. Yes, I remember now. Okay, so let's go this way. So that's what we put together this week, and I think Minion is gonna highlight it in the carousel if you can there. And actually, you know, it looks better than if you look the listing. If I'm looking the listing on that, I'm gonna click on it here because people let's see what showing there for those on YouTube or Facebook. I'm gonna click there here a little bit, guys. The links are available, or just join us here on Amazon. The link is over there on the listing as well too. So that's what we put together. $69.95. We built this. You can run it with Raspberry Pi 3 and 4. I say once again, I would recommend to you guys and run it with 3. It doesn't require run 4. It was pretty cool. I think even mine looks a little much organized in cable management. There is 2 ways to run this thing. You have to choose whatever you want your camera, or use the ultrasonic and detect like distance and all that. I think the camera looks cool. Too bad you cannot use both, but you have to decide. If you want to use this, you have to take apart a few things and put it back. Not a big deal. Comes with a good PDF and a good instructions. And like always, this company tend to keep run out everything and show you, okay, what is the different inputs and output. And we're going to review the PDF a little bit. All right. I think it's a great price, $16.95. It does require memory. It does require to get the batteries. And does require to get your Raspberry Pi 3. Okay. That's extra. Very important. All right. Very important. You need to get that. I mean, we do have here and Raspberry Pi 3 should be around, if it is, available from all the sellers now. Okay. So that must happen. Or you can search for them. Okay, that's a good price. We have here $41. This one was nice because it was around $37. Yep. So that one went up. But now with carousel, you can then move and look. Let me give you an idea here. You have the $41. Well, I mean, yeah, you can replace it. Oh no, here. 37. Oh, because this is plus
It's
B.
okay.
Plus B. Okay. So this one is plus B. This is one I'm using. 41. Because you got the plus, you got the 8B and the 3 baud. It says new revision. It's just coming up with a different revision, like always. All right. So that's great. We have all this. Memory wise, this is my memory. What I do recommend for these type of projects. I think it's a great price. You get it for $15.49. You get 3 memory pack. If you're gonna be building out of this thing, I do recommend to get the package of 3. All right, so get the package of 3 memory. A great price. You're looking less than $16 a piece. All right, and if I go and troubleshoot, let me see. Battery should be here. Okay, so the other batteries, the different with these batteries, a little more expensive, but it has 3,400 milliamp hours. We see there. Normally the other ones are 24, so you get more power on battery wise. You see right over here, and that means more time playing around with your robots. Let's see the height I just saw up to now. There are possible the higher ones, but I'm trying to search. I couldn't get one. So if anyone knows a bigger battery in this, please show me a link. Show me a chat. All right. Or you're run a company of batteries. Just let me know. You know, we got the email there. Let me know, because I'm always looking batteries bigger than this. And this one got to charge it. So the charger comes handy. Because some you can charge it by plug it in. But normally what I do, I just take the battery out of the car, dump it in there. I have 2 charging right now there. And I just dump it in and charge the batteries. And these batteries are the 6A. I should remember by now the number of these batteries. And it's the one. Easy way to remember this thing. That was right over here actually charging. It's already charged.
Isn't that a 665?
Yeah, it's 18650. 18650. These are the batteries you guys need to get. All right. So if you run a company of battery, let me know. Shoot me an email. All right. That's what he got up to there. Okay. And other project we build this gray spider as well too. Just to recap a little bit some of the things we build. We built this one. This one is the biggest guy. This will take a while. This is a powerful one we built, and about a month ago, even longer than that. Then we build a dog. All right, we build this cool dog. Some things coming up. Some things it will coming up, and I think that next week, if we are all on time-wise, maybe. So we have this one coming up. That's the P-Car Pro. All right, not confused with the guy from P-Car from Star Trek. Okay, next generation. So we got this one P-Car car. There is 2 ways we can build it. I'm sure I'm going to try this and then do the little car. It looks real cool. I have it right over here. I like the LEDs. These LEDs, they're huge LEDs. And even the one in the top that went. And I think it's going to be a great thing to put together. It does require Raspberry Pi 3, guys, for this, okay? I think it comes with batteries. I think it comes up. I'm not sure. I'm not remember. But we checked that. Check that out. All right, and just to recap a little bit, so what else we have here? I think I put another robot here. Oh, we did build this one. All right, we built this guy as well too. That was real cool, this guy. We put that together. And what else? I had this Spire 2 times, maybe no. Maybe it's just here that way.
Different.
Okay, I thought I have the Spire 2 times.
Tunnel.
Yeah, I know. And well, okay, and today, guys, this is what I'm going to be building. All right, so this is exactly what the project we're going to be doing today. Okay, so this is Spire robot, an Hexapod, and walking crawling robot, self-stabilizer based on MPU in 650 gyro sensor. So that's a gyro sensor. Again, this is STEM, okay? Science, technology, engineering, and A for what? Math? No. What was A?
That's it's not really A. I mean, you can put A sometimes.
Sometimes they use R. Yeah. So it stands for science, technology, engineering, and math. In the A, sometimes they use it for art. So that too. I think that's why they use art as well too. So we have this great project based on Arduino. There is no Arduino to need to get to anything. This project self-contains. So it's everything there. You don't need to get anything. It comes with battery, comes with everything. The only thing we need to download a few things. And that's it. Right? And we're gonna plug this all together and let's see how this one goes. I think it looks pretty cool. If we look some of the video, I don't see videos here, but they got some amazing video, the things you can do with this little robot. Looks real cool. We're gonna put this together. And normally it's gonna take 2 Saturdays to put this together, guys, just to let you know. Because we're gonna have to check and go step by step. That we're gonna put together, we have to do step by step. Okay, so that's for now. So let's go back now to the little car. All right, and I think again looks a little better. So we talk about a day, maybe 6-5 hours. I think you can do that free in a few hours, right? And again, this covers all the ages. No matter how old you are or how young you are, I think it's real nice to put this together. You learn some mechanics, learn some cable management, you learn some little programming, learn how to put things together. Great for kids, children, adults, anyone, right? You spend a good time putting something together and then go have fun. Or just collect it. You know what I mean? I'm not using these every day, but eventually we'll have a shelf full of these cool things. And then one day I want to pull it and run all these things. But the thing is, yes, that you put it all together all at the same time.
Welcome to MEDIABOXENT on Amazon Live. Ask your questions. We're here to help you. Today is Robotics Day.
Yeah, so that's a fun thing, right? Sometimes we just put things together and we just leave it there and you enjoy it. Oh, and you look at it. Oh, man, this is cool. I think I like the cable management I did here.
You didn't give me the wipes for the glasses.
Huh?
You didn't give me the thing for the wipes for the glasses.
Oh, it's here.
I will go and get one afterwards. That's okay.
Yeah, cool. I use it. Oh, and I think it looks pretty cool. So let's see how that works. So we have the Raspberry Pi 3 in the bottom. Sandwich format. This is what they call it, the Freenove. The company creates their own board. And this is like that's the one interface within the servos and the lighting. It's something that allows you to connect everything. And the nice thing is the way it works in this case, and runs a mini server and a web page, a page server. So you log in into the port number of this thing. I think this is what I did. I gotta look. I try to remember because we create so many of these projects. I think that's what it is. I gotta check the IP address and type it. I get confused also with another robot that controls through the web page. But I know I can control this with the app. 2 motors here, very fast. Here, so we have this servo here. What we'll do, it will control in the move of the wheels. We can change the light here, the LED light. Right, and this is a little beep, and this is the camera. Now we can say this is the back or the front, whatever you like, right? So maybe this is the front, I will think, right? Or can be this is the front, right? I don't know, back or front. And because if you look this way, I will say, well, okay, I think this will be the front, right? Like a tricycle. That's the idea, maybe. So the camera connects through. It looks like it's a regular USB camera. In this case, most of the projects we use in the Raspberry Pi camera. But in this case, I think maybe it doesn't break because that one has a special cable, the flat cable, kind of tricky in that case. So maybe they use this. Seems they got the drivers in Raspberry Pi recognize that, right? And then we power it up the Raspberry Pi. Through using a USB. So we're using this USB to power up the Raspberry Pi, and they use these batteries, and they keep about 5 volts. These 2 batteries here, and that's it. I think it, guys, so you can see it what this project looks like. We completed last week on Saturday, and I think on Sunday, and what I did kind of fix up a little bit this, right? Sometimes I do an live stream, or sometimes I do an X after. And then I went to a little bit on the programming and see what was missing. What I want to do, and I want to get this page out of here. And let's recap a little bit so we can move to the next project. I want to get this thing running. Let me clean up a little bit here. I want to get this out. So let me get the PDF.
Welcome to MEDIABOXENT on Amazon Live. Ask your questions. We're always here to help you.
All right. So robotics. I'm gonna bring this so that way we can close the project. You know, that's the way I like to do it. I wanted to, because you know, there are a lot of people follow this live streaming, so I want to make sure you guys know what we add all the time. So you know when you come back next time, okay, oh, okay, it's nice. Dario recaps a little bit, then I know exactly where they finish. Okay, dog, okay, and tank, and spire. Oh man, what is my my 3-wheel car thing? Why I didn't put it here? Raspberry tank. Did I leave it in my downloads directory? No way, I did that. Okay, I never do that. Or maybe I did this time. Car. No. What is my project? Project! What are you? What do you want? What my project want? Okay. Free move. Let me see. Okay. 6 leg. Firebar. Okay. A tank. Ah, man. What I just did. You know? I lost the project. I need my project. All right, let's go get it. I need to get the project going. All right. I'm going to go into the company webpage. So give me 1 second and let me download this thing because I don't know what I did. Normally,
welcome to
I save this thing
on Amazon Live. We are putting great robots together today. So the one that we're putting together today is like Hexapod, but this one I think is smaller than the other one. But we're gonna see like at the end how big this is. And
I think it still looks pretty big compared.
I think so too. Yes.
And compared to the other one, okay. All right, hold on. Super 3-wheel car. Okay. Okay, I got it. So normally, yes, you have to go into the page of the manufacturer and download. A lot of these companies do have GitHub. Very important for that. Makes the project nice and smooth because you just go and download the stuff from the GitHub. You don't have to go and copy stuff and, you know, and get a little crazy. And okay. So I got it here. Let me copy to my network drive so it stays there forever. So, okay, good, it's there. Let me bring it up to my desktop right now. And let's run the wonderful PDF here, tutorial. And all right. So this is a recap of what we did. Then what we did last week, okay? I'm going to go fast because it's a lot of information. But normally this is what the instruction from this company intend to do. I think everything becomes pretty much clear. This is the car, what we put together. And let me make this a little smaller. Okay. All the screws and parts that require the 3 cars, right? This is a recap from last week. The parts we use. Again, we're looking at the project we complete last Saturday. And it gives you a run now on the Raspberry Pi version. And kind of nice. So if you have no idea what the Raspberry Pi is, kind of show you different models and all that. And then give you, inputs, outputs, and, power, how the whole thing works. Then they give you a layout, the ports, right? That's the way things talk through ins and outs, right? And that's the way you'll be talking with all the boards and be able to control LED lights and be able to control things here. And a 5-volt grid, 3 volts, -5, and give you all the information here, right? Power-wise, what I was showing in the beginning, how much power requires each, and what regards a manual, yes or no. One recommendation I give it to you is in the beginning, we don't need that today now, but I do recommend have an extra monitor, and I do recommend an extra keyboard and mouse. It can be wireless keyboard and mouse. An extra monitor, any monitor can do that for you. Now, if you are super advanced, well, you will know how to do it with you can do it without even connected, right? And you just but that gets a little more complicated, right? And you can do that without even connecting a monitor. There's ways you can do that to control. Through Pori, you can do it on Windows. And then give you, and if I go back here, this is my window for that now. Sorry, not that one. Here. So you need to download the little version. It's going to give you that, how to download Raspberry Pi. How you to control. My recommendation to control any connection with the Raspberry Pi is use BNC. It's a free software you can download on your desktop, and then from there you can control all the devices Raspberry Pi. I'll show you mine. You will see all the robots being added up to my BNC. It's part of the Raspberry Pi, so you can activate that. It will show you how to activate this anyway. In my tutorials, I show you how to do that. All right. And again, they give you a layout how the port works. There is some change we need to configure in Raspberry Pi and Python. We did that last week. I'm going to move forward fast a little bit. And here they give you how you're going to start putting stuff together. There's a lot of tests in the beginning. This project make me do a little test. Don't know why, but that's fine. It's more to know how things works, but they give, okay, test this out. Now, put the motor on. Try this. Try that. See, it made me do these little things. With other projects, you don't have to do that. Kind of thing, and the next project is going to be the same way. Okay? So you guys know. I'm thinking the next one is going to be based on the same type of project. Again, we'll look at all the instructions, right? And let me move into the assembly of the car. So we did assemble the car. We put that together. I'm going fast, guys, because we did that last week. So and again, to put, I'm going to run the car. And that was pretty simple. Not much into it. I think it was, after you see here, I think I didn't make any mistakes. Sometimes I make some mistakes, but this time was not. It was a little complicated with some of the things on the software, but I got it working. It was just maybe me and turning the server on. So here they show you how you get it. You need to log in into your Raspberry Pi. And I use the remote and give you the codes and everything to test around and how you get the clients running. I think I should run it. And this is the software. So there's 2 versions. We can straight log in into the car. Or we can run it. Oh, I remember now. So we need to run Python. So we need to install Python on Windows. That's the part I'm missing out. This is the part I didn't went through because I need to be some. I did it required me to do some reading and figure out why was not working. So it took me sometimes on Sunday just to get that going. So I remember now. So here keyboard decline on the Windows, right? If you got Mac, you will have to install on a Mac. So you need to download it and install the latest version of Python, because we're going to execute the software here on my PC. Or we can do it through BNC. I think that's the way I did it. So here's the installations on Windows. I tell you what to do. So we have that installed on Windows. And then I think I control it with, they give you here, make sure all that is working. I need to install another software that was the QWicket. I think they have to install that too as well, because if not, it didn't work. So it's something else installed. This one, I think. It will tell you to do that. And we can connect and control. And I think we're going to do that right now. All right. And keys, how to control the car. All right. Or you can just use the mouse. That's what I did. And then it goes into software. And if you want to know how to run it, right, there is all the configuration to start automatically. I think it should start automatically. And the part of installation here, the auto start. I think mine starts automatically. Here is how to edit to auto start. I don't remember if I did or not. Maybe I did. But it service should start automatically. And now we can execute it. All right. And this is through the app. All right. And to run into Windows, we have to tap Python. Run to Windows. How we did that? Now I have to refresh my mind a little bit. Okay, so how we did that? Okay. Oh, so we did this. Oh, is it the drive? I don't know. So let's see where I put that out. Let me go and check. Let me go and check where oh, maybe I put in my C drive. Oh yeah, I call it car, so I don't have to go crazy and type in the whole entire line. All right, I remember now. So we need to open a command prompt here. Okay. So let's go to and try that. All right, and we can we see that? Yeah, there was all black. All right, there. So we are on Windows, so I should go this way, and then CD. I think I call it car, so I have to tap the whole entire thing on it. So if I type this Python main that here, it should start the program. No. Oh no, I have to go to clients. I need to go into clients. And to clients I need to go. That's what happened. That's what happened. All right. So now, or you can just type, Python, and you can put the whole entire directory if you want. All right. So if I do this, okay, and we got a little car going. Let me take some of these things out here. Okay, it's a little smaller screen. Let me get there. So it's running on Windows. Again, I did this part offline, means that this was not part of the live stream, the whole installation on that part of the PDF. So now here's this 146. So if I start my BNC program, and this is all the stuff, you see why you want to connect it. Okay, it's 146 maybe. Maybe it's 146. So let's turn on the car. Again, we switch screens. And pretty simple. We're gonna press. So there is two buttons here. One is called control. Control is software-wise. Raspberry Pi, another servo. So if you're going to be programming this thing, then you just go control. You don't need to waste the energy on servos and all that. But we need to press this, and we're going to press that. All right. So automatic, that real fast. I like the star. But I have to wait until load up, so we can see Raspberry Pi is loading up there. I think we can see the light. In automatic, this is lock. Everything is in automatic lock here. So let's wait and see if we can control this for a second. So it's still loading. I see that the green light there. All right, it's on. So now, in reality, if I wanted, it feels okay, and I want to log in into my Raspberry Pi, let's try this up. I'm in. And that's why you want to run BNC, because now they've had to do something. I think the server is running. Let's see now. If not, we have to execute an automatic thing, so it runs all the time. So let's try it. So 146, I'm connected here. In reality, you don't need to do that at all. But what I'm going to do now, I should be able to control the car. So let's see if it's all fine. Okay. And 146. So the server is not running because I don't get response from there. Okay. So the server is not running. Let's go back. And I need the PDF again, but I have my PDF running. All right, so let's get that a little bigger so I can see. You guys can see. Let's move up all the way to the bottom and see what's going on here. All right. Let's begin the server. Let's look to start the server. So this is the client, but I need to start the server. Okay. That's the Windows version. So I need to go back a little bit. Client. Okay, server. Without GUI. All right. Or with GUI interface. Let's see. This is with GUI interface. Let's see. So it means I have to execute that. I forgot to do that then to start automatically. So let's keep this inside. Let's bring back this. Let's open a shell prompt here. All right. Let's get this guy bigger. And let's just paste it on it and let's begin the server. I thought I did. Okay. Okay. So we need to make this to go on automatically, okay? Because I want to make sure I do that, and if not, I'm not going to remember. It's from the car. Why can I control the car? So, okay. But it's running there. So, technically now, let me put that window on the side. If maybe it's already connected. All right. Connect. Now you guys see the camera. All right. You see the camera here. You see the famous jellyfish. They are off right now. Let me turn it on my jellyfish here. Let me turn on the jellyfish. All right, we get the jellyfish going there. So that's a point of view of the robot in the back, the car. That's what the car is in it. I can bust this thing. But what I need to do for you guys, I'm going to change the screen for a second. Let me get my software going. And I'm going to bring another camera into this screen. So we can all pick. Because it's okay, if I want to see what you guys doing. We don't need this because it's connected. And I believe we're going to reset in a second. I believe it's already there. I just forgot to connect this up. Right? We're going to leave this minimized. So this is running on Windows through Python. We're going to keep this here. But we're going to use the wonderful things here in MEDIABOXENT, and I'm going to bring you a new camera from the top so we can all pick together. But I want you to guys see in the same time what we're doing. All right. I'm going to bring that a little bit there. Not much, but later on we get a full view of this. All right, let me put this maybe there. Guys, if you have any questions or anything, please do not hesitate. Let me know what's going on, and we stop this anytime to review. All right. Get in. All right, so technically, what we see here, so I can, let me see, I can control here. Let me see how I control servo. So this up, you see that? I can control the camera up and down. Did we see that going on there? Let's focus a little bit into the card right now. So down, okay. And we're looking at the jellyfish. Let's go up yeah. Let's go to the left. Let's go to the right, right? And that's the camera for the jellyfish. So the camera in the back. I can turn on and turn off the buzzer. And I can change the colors of the blue, green, and the red is funny. But it has to be the software, because through the app I can control the colors better. I know the red is a little, it's not 100%. Don't know what happened. But I guess you can just change the light, whatever light you want. You like red. I'll get red. It's green, Cyprus red. And that's purple. You will see this mismatch. I don't know. Maybe it's just the way it is here. Or maybe because it's RGB. Let me see. There's blue. Now it's red. Or maybe it's just a combination of color. Whatever. Alright. Okay, now I guess you just where you combine the colors. Alright, so, and we see the cool LED light. Question. And then it has a calibration here. But let's move up. Down, no. So I want to go forward. Back.
Hello, Amazon customers. Thank you for following MEDIABOXENT.
Yeah. You see that? Now, to be able to control left, and then we can control the wheels there. So the idea is let's see, and I think with what, W? Yeah, W and D, right? So D in the keyboard. So now if I want it, and then S is back. Yes, S is back. So if I hold the keys, right? So A, W, D. So A and D, left or right, right? And so I can be pressing the same time and move it, right? So I can, or I can go back. And let's go back. Let's go forward. But let's go the other way around. See? And I control that with the app. Let's go full screen now. I know there's not much space to move around on my desk, but this thing, everything is fast. Hold on. Let's stay there. And again, I can control the speed as well too. So if I want that to be super slow, it's too slow. I think it needs to be around let me see, 20. Yeah, 20 is not. See that's much slower. But if I go to full speed, it's fun. It has this thing has a lot of power. This little motor. So wow, you see that? Oh, kill my mouse. This thing is fast. So if you go full throttle, and see, let me put my hand over here. That's fast. That's fast. So you can be, you can move this around, and you get a camera, as you see here on my window screen, right? And I think the automatic. I think I did the installation already. Now, how about the app? The app, you need to download the Freenove app. but you can control many of those devices. Should have that. I should download it here. I don't know why I don't put it here. Let me go ahead and grab it from my other phone. Okay. Let me grab it from another phone. Let me close that run. So let me grab from another phone here. So I'm going to disconnect from this. Okay. And we have the different robots. Eventually I want to build these robots. So we build a bunch of this. I think we have this coming up as well too. I think this guy's coming up too. We built this one already, the big one. Alright, we have a lot of more robots to build. So let's go on 3-wheel car. Alright. And we need to put the 146. Normally what I do, in 146, on my IP, in the beginning I put dynamic IP and then I change it to static. And 146. What I need to do, I have to actually get a little like sticker and just put the number here so I remember, 146. If not I have to go into my BNC and look. So connected. So in reality now, if I should be able to change the colors of the light, let me see. No, connected. Come on, baby. Now connect. No, fail. All right. Let's see, white. All right. No. Okay, not connect right now. 146. Yeah, let me see if I can connect with the. Yeah, disconnect. No, so I think it's on time. Maybe it's my my phone that does that. I need to download this in my other phone. I get too many messages coming in. All right, so let's do this. Let's turn this off, and let's turn that off, and turn it back again. All right, and let's see if I'm right that I already did the automatic server startup. And if not, I have to do it. We need to check that in a second. We're rebooting the robot. It's a robot. It's a car robot. And then we move to the next thing. Remember, every Saturday after one, we do have a lot of robots here. We put together a STEM toys. We can call it a toy. It's a toy. Maybe we can call it a toy.
Sort of toy, like in a smart toy.
In a smart toy. It's a toy in a way, but it's more intelligent toy. It's beyond a regular toy. Okay. Go back again. And okay, so I filled in here. I think maybe it's because I know it's control it. My question is, let me see if automatic starts. Yeah, automatic starts. So I don't have to do the program. I guess it was part of this. I think it was part of this. So when you install from the Game Hub, it does all that for you. My question is why my phone is not getting connect. Let me do something here. I should download in this phone because my phone gets always message everywhere. It's a little crazy trying to. Okay. Oh, maybe I have a problem with my network.
Maybe because my computer is really, really, really slow.
No. Okay. Oh, see, I'm connected to a light here or something. Okay. All right. So let me get this software going. All right, now, and company. Should we call that? If you look in the free. Okay. So it's called Freenove, right? Yep, it's here. Yep. So if you're gonna be doing these type of things, so let's take my phone off. And what we're doing right now, we're installing the app. Let's see if Can be also my phone. All right. Plus, I need to use this phone. This is my super phone for all these kind of things. So we have all these projects here. Build a bunch of this already, guys. So let's go to the 3-wheel car. Okay. And let's change the number to 46, 146. Get connected. And I'm connected. Check that out. That actually works better than my phone. You see that?
Yeah. Super fast.
You see that? So camera here. And so I can change the light there. Should be able to change the light there. No, change the light. So I'm connected. Alright, hold on. But also when it talk to me, I just talk to the camera, but not to the rest of the car. Very interesting. I don't know why that happened. Huh. Because the other one, I didn't have that car, and I didn't have the screen. Alright. Yeah. I get the... Okay. Okay. I don't know why it doesn't want to connect here, but that's great. Alright. Give me my phone too. See, my other phone will have a problem. Now this one, I get camera feedback. I get my camera there. On the Raspberry Pi runs the server. Alright. Alright. Oh, that failed. Okay. I don't want to connect it. I don't know. It requires some study, like always, you know. So part of the fun, part of the project. Then you need to. But I know if I connect here. Oh, all right. Okay. I problem crash. All right. All right. We know if I connect it through there, but that's the thing. Super fast. So just put it around the computer, have your phone, and just play around the house. Yeah, I don't have much space to do that, but it's a cool project. It's a cool car to have fun and put that together. Just put the battery, charge it, and have fun. Man, things gets warm. I can feel the heat out of this. Okay, so that again, that completes this project, this wonderful car, and that we did put together. And that's it. We're gonna move to my next project. What do you think, Mina? Great?
I think that's an excellent plan.
Excellent plan. Keep it in the floor. We need some space for that.
Yeah, check the messages more.
Okay.
Yeah, we're gonna go to part 2. You decide. Yeah, maybe you can do the open box and then we come back putting it together.
Okay. All right, so let's see what we got here. So, okay, so move to the next.
The big one?
No, the Hexapod.
Oh, okay. Oh, the very big Hexapod? Oh, no, wait, the first one. I got it, yes. The new one.
No, the new one. All right. So this is what the next project we're gonna be working on it. So I think most likely will be right now will be 2 Saturdays to put this together. So this one is Hexapod. So Aspire. Well, the Saturdays, yeah, 2 Saturdays. So an Hexapod here in a robot kit. Put this here because see what's going on. Okay. And it comes with everything. Let's review a little bit what we get. Again, you need to download the stuff. They'll give you here a card where you're supposed to go and grab the stuff if you need information. Already there. Already always download the stuff out. In this case, no Raspberry Pi required or anything else. Doesn't require you to get either Arduino. Okay, comes built in with the Arduino. Some of the things here comes with the screwdriver. All the projects comes all with the screws and everything else. So it has the screwdrivers, it has the plugs, whatever we need. So we have here, and I think this is the Wi-Fi controller, and the micro sound, ultrasound. Okay, we have some LEDs. I think this has to be the gyro sensor. This to hold the batteries, but
the ribbon is like, yes, to take out the batteries.
I don't use that. Okay, yeah. And a battery holder. Cancel the batteries already, and charge the batteries. What is it? Because one battery. Okay, yeah, batteries are over there. I should put it here. The batteries. It's already full. Oh no, because no, not yet. Because we're gonna have to put this, or maybe we have to test. I don't know. So this is the Arduino combination with the board. Alright. I think as part of the listen, we're gonna have to put some. We're gonna have to run this first. Okay. I will say this is the first hour or two. Give you an explanation how to things put together, and yes, and test the things around. So this is the board, and we're gonna see what each board is what for. I can see this is for the battery, one is for the Bluetooth, another one, and this is the servo control. Okay, so we have servos here. So we're gonna have a half a dozen or more than that, or 18, I don't know, many of those. All right. We have all the servos here. A lot of those guys, right? Nice little cable management. Since I have all the robots, I save these things all the time. And we have the screws. And the cable. Alright. And we have everything here too. Everything looks real nice to put all together. So we have all these parts. So it's nice. Every project comes with their own things, right? Comes with everything. And that's nice. You have to even go to buy you don't need to even go buy tools or anything. So if you see, say, okay, I know how tools at home, and sometimes we don't have these tiny things. We don't have to, because it's part of the project. I like it. So that's why we trying to get more projects. We're gonna try to get more things into it, so we can and build more of these type of things, right? All right, so all right, we get that. All right, man, what a nice day today. It's supposed to rain tomorrow, but what if they have all the windows open? Super nice today. All right, so we got that going. But before even we move to this, all right, so we have all this. What else? Screws. And by the way, then all the acrylic. That's pretty heavy acrylic. That's a pretty heavy acrylic to put together all these robots. And I think it looks small, but I think it's gonna have a decent size on this. Well, compared to my previous robot, right? Compared to my previous one, it was pretty big. All right, we got that. So let me put this into the side. No longer need this. Go to the garbage can. Oh no, I can't right now. Okay, that's fine. All right, so let's switch the screen. So what I did, I went to the main site of the company and download the PDF. Right, most of those you have to do that or get into the GitHub. This one we have to install Arduino. I used to have my other computer Arduino because I did some project Arduino, so I'm gonna have to install it here. Nice. going to be working on it and this and show you how that works. Let me kill my server here. And that's where we are. And right now we don't need a camera. All right, and the background in the corner below, right, myself, you'll see the project we're going to be building on it. All right, so that's the little guy. And if we look in here, that's a directory download. Okay, they give you instructions how to use this. Let's bring my PDF here. Let's make this big, and I don't know if they're going to show you. Well, here they show you how the whole thing is going to work. All right, thank you very much for using this product, blah, 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 blah. Okay, so to find, you need to open folder 01 course manual. So they are manuals, they are lessons, right? So the course lesson robot. So every lesson is very important. You must learn in order, right? Second is the software installation package. The third is the code, right? And very important, especially the store code, the program that control the robot. So I guess somewhere there, you're gonna be how to put this thing together. Now the idea of this, right, is to allow you to better learn and use the robot products. Carefully prepare the information package for this robot. During the process, we hope you learn in order to use the course. Once you need to find the idea for that, the idea is, again, if you don't know anything about it, I think in this one explains in this one. See, okay, so the company of tech, I think decide to apply the internet. Let me see here. We have trigger provide. Okay, it doesn't show here. Well, but I read it somewhere there. Maybe it was in the other one to show you why they did that way, or maybe in the first course. Okay. So here we see, so course manual 1. So let's go there. And it's a lot of 12, 13 parts. Then software package and code. All right. So this is a big thing. Somewhere there should be how to put this together. We hope so, right? So let's go for the first part. Introduction to the Hexapod. It's by Robot. Lesson 1. Okay, introduction to Hexapod. Spire Robot. Introduction to Hexapod Spire Robot. This is also open source. Oh yes, open source Spire Robot, which allow anyone to build, right, own working robot. No period knowledge on robotics. And that's nice. That means if you don't know anything about robots, if you know anything about those wonderful spires, they go around in the basement with the most big leg, scary ones. Sometimes if you have a basement, or if you live in Australia and they got those big ones coming up at you, you want to run close, or you're someplace you have to look, or you have to look your sneakers and make sure that no spire went in there. Okay, so here, thank you to follow Amazon customer. Thank you to follow MEDIABOXENT. All right. So we are super excited to build this great robot. So we having fun, very on Hexapod robot. Yes. Right. So this is high quality acrylic extrudes, high quality acrylic. After to make the body robot custom print, you have to so custom print boards through the board. The pre-programmed Arduino controller and ultra range sensor, the ESP8266 Wi-Fi module. All technical stuff. Okay, so the Arduino APP, a communication between the APP and the robots based on Wi-Fi controller through the APP. I remember my song. APP. I remember my song in the 90s. Okay. So, what includes? So, this is STEM. So, it's educational. What we said the STEM stands for? What we stand for? So, science, technology, engineering, and math. Well, how about the A? It can be art, and they do. Also, art is part of the STEM too. All right, so we got that. So the robot, so it's complete. Bionic. Wow, this is the Bionic woman or the Bionic man. Oh, that was the $1 million man. Okay, so the Bionic man Hexapod kit based on the Arduino, remote control, APP, Python GUI. You can control this with the computer or the Wi-Fi. Easy to assemble code with the PDFs of the manual. They'll include powered by two 18650 batteries. Not included. It does include in this. Okay, so it seems to be included. Maybe maybe before they include it, maybe people complain because you get this. Oh man, now I gotta go and wait like 2-3 days to get my batteries. I cannot go and somewhere else and buy this thing. So, right?
No, I don't think you can.
No, they're hard. You're gonna go to like a John Doe. Can I have some 1850 batteries on the hardware store? Well, the store we know, the biggest store, sells a lot of hardware.
You can do that, yeah.
I don't know what is that. So imagine that. So that's why they include it. Well, I'll let you know on every project if you need to get that. Okay. And then, and this is the breakdown. So we have designed basically advanced course for the Hexapod Spider robot. The course is very dedicated and open source. So we have made they give you that explanation here. The list is very careful for you to list of the Hexapod robot. And they break it down in different directories, right? That's what we have to here. And that finished now. I'm just trying to go down. So this one, I just give you a rundown and used to the Hexapod robot normally. So this one, they give you all the things here, how to put that together. And that's introduction 1 for this. All right. Let me check something out. All right. And how are we doing here? All right, Mia, you want to come back in a little bit?
That's a great plan. Yes, let's come back with this. Awesome.
Okay, so we come back. Okay, bye. Okay, so those on YouTube and Facebook, we're not gonna wait. So hold on a little bit. Input. So hold on. Like 5 minutes. So we just we need to take a few seconds out of this. So if you guys watching this, we just in the one connection, we need to wait to refresh a little bit, and we'll continue with this and building this.
And we're still here.
Yeah, building this great robot. By the way, for you guys, what we do with streaming. Let me go this way. We're streaming every day on Amazon. So we are on Amazon Mondays to Fridays. We start at 5:30 in the afternoon, and it's a tech mixed with electronic. Can be sometimes all kind of things at home and all those items. Sometimes those items you eventually see here and then on the YouTube channel. Right, so that's why you see sometimes all these new products or these things we bring. Eventually, you see open box of this, right? We did you will see actually this video coming up eventually. You will see all these projects done. There is little videos which show the project done because we already did in the live event. So we have a lot of cool things here on for this particular YouTube channel, the lab version, right? Because this is a breakdown in 2 channels, by the way. It's breakdown the Spanish channel, it's called MEDIABOXENT, and then the lab version was the English channel. Oh, there is the English channel.
Oh, do you want coffee, by the way? Sorry.
Yeah, I get coffee. So what we did, right? And then we started the beta version about over a year ago. We started with Amazon as a beta guys there. We started almost in the beginning, like almost 2 months after. Mm-hmm. And we
got that call.
Huh?
You got the call.
Oh, I got the call, yeah. And then we did about 2 years and almost not 2 years, a year and a half ago. But February 19 was a year with Amazon. We're doing great. So a lot of fun there too. So we are there every day. And then I think this is a cool a cool project, this one. That's why I bring this the live event here on YouTube. Or we are live when it's something real cool, like prom day, all those things. Maybe I do like multicasting. I multicast all the time on Facebook. So that's Facebook is a multicast all the time. But on YouTube version, it's only like this project. I think it's real cool to put it in. And by the way, we're going to have a lot of things to show you guys all the time. There is like, I don't know how many videos on the queue right now. We cannot release all the videos in one. So we space it up, the videos a little bit. So there is a lot of videos, a lot of tech, from bicycles, from, I don't know, a power bike, what we have.
Electric bike, electric scooter,
skateboard, all kinds of crazy. Overboard, cameras under the water, robots under the water. We had to try that already, by the way. I think we should go tomorrow. So we have all these cool, amazing. I think that one we maybe did the video already now. So we have these cool, amazing things coming up on this YouTube channel. And that one was just saying, just in case. We're just taking a kind of weird break I'm taking. It's called technical break.
Yeah, you tell me.
And all right, just hold on. Let's call on 5 more minutes. You want to make a coffee?
Yes, I'm gonna go.
All right, so we come back. So this is a multicast. So what I'm doing, I need to wait. I'm gonna reconnect again with Amazon in 5 minutes. We continue. We're gonna do the connection again in 5 minutes. Gonna continue. I don't want to cut this up because then I will have to call this, part 2, part 3, part 4, part 5. I don't want to do that. So we take it in 5 minutes, and then we come back to this. Oh, we should watch what I'm watching here. All right. And then the cool thing on the Amazon thing too, that we have a lot of promo codes too, as well too. We always get promo codes. And by the way, on robots wise, we are almost like booked for another month and a half or 2 months. I think maybe 2 months worth of projects for robots, and continue. Menina, she's in the background. She's in the mornings, by the way, but it's not a tech related show. In the mornings on Amazon. And so Menina is in the background looking for all those things. So we have about maybe 2 months, I'm saying. Even to begin of the summer on robot. Then I'm sure we're going to have more coming up. We're trying to get more advanced into it. And sometimes we get some little ones too. We got some coming up. Maybe, about a month. Maybe less than a month. And they are like tiny versions, tiny for children. So that will be simple. That's true simple. And I think we can definitely build 2 robots in one. And that's all we're looking for. Or we can just do one, but in reality, I think because they're kind of small, I'm thinking that way they all can be different, and we can build 2 robots in one show. I set it right now. The time set is 1 o'clock. I know today we're a little late into it, 15 minutes late, but it's set to 1 o'clock. How long the show lasts? I don't know. Normally, I don't know, it can be 5 hours, 6 hours, depend. When I'm tired, my friend, when I get okay, I think it's time. I think it depends how fast I advance on the project. That's okay. I think it's good to leave it for now. Let's leave it up to that point, and then we continue. Let's say the follow Saturday. Okay, normally, sometimes it's just a combination. Have the file or have tired I get. It's okay. I think I started making a lot of mistakes, so I think it's time to let's go then and let's take a little break on into it. All right. You want to click in? Go for it. I do the whole introduction again, okay?
Okay. Hold on, let me see something. Hold on, let me see the first. Still there. Okay.
Yeah, I think that's
the figure.
Yeah, I think that's what happened.
We can say that here, right?
All right.
Okay, so I'm waiting for the signal.
All right, let me activate that. So we go back, guys. So for those who are watching on other networks, we're gonna introduce ourselves again, okay?
Yes, you're gonna think we're crazy. We are too, but we have a reason now for it.
Yeah. Okay. So let's go for it.
Yes, I need the signal.
We going?
Waiting for it. Okay, you're live now. Live, I just don't see a chat on the group.
All right. Okay. How we doing, everyone? Hold on. Yes, I'm lost here too. What I'm seeing here is I don't know what. All right. So hold on. A second. Satoshi, what's going on? Every time go live streaming, you start crying.
No.
He knows that. He knows that. No, not that. My life events here. All right. So how we doing, everyone? Once again, part 2. Had to put robots together. This is the great show right here in Amazon Live.
MEDIABOXENT.
MEDIABOXENT. We put things together for you, and you're on it, and then you go and put it together. So how we doing? Wonderful afternoon. Part 2 of this wonderful show. We building today robots like every other Saturday, not every other. Every Saturday we put things together here, and yes, and today we have the second part of this wonderful robot. We're building a Spider Hexapod. If you like, guys, looking underneath on the carousel, you will see this wonderful robot. It runs in Arduino. Doesn't require anything special. Means no batteries I need to go there. It comes with everything. No memory or that we need to get an Arduino. No Arduino required. So that's a wonderful thing. It has everything on it. And let's go real fast because this is part 2. A lot of people catching up on the second part, and this is who they are, these people. Who we are. Who we are is this. Who we are. Okay. So this is Dario from MediaBoxENT. That's not Menina. There. Sorry. Wrong name. Alright, so this is Dario from MediaBoxENT. Behind the camera.
Minia Muro, I'm always ready to answer your questions. Welcome to MEDIABOXENT.
Yeah, catch Meninas in the afternoon, by the way. In the afternoon.
Morning.
Early morning. Monday to Friday.
Right here at MEDIABOXENT.
We are available for chat.
We are always available to chat.
Okay, all the time. Ask your question there. And then, next one.
Follow MEDIABOXENT on Amazon Live because we have great open boxes, exclusive coupon codes, and so much fun and many robots, as you can see.
All right, so this is the second part. So now we'll go in. Can I model this thing up? Okay. So let's see right over here. All right. So we're building this great Hexapod right over here. I'm going to change the screen and show you what we're building today. We're going into introduction. So if you capture this right now, it's the perfect part because we're moving along. We didn't put anything together yet. We follow the step from the manufacturer hand to put this great robot together. Right, everything control with the Arduino and Wi-Fi, and also you can control this with computer. I think it's going to be a lot of fun to put this together. Right, it's going to be fun, and this is our 4th or 5th project we're already putting together.
So many,
and there are many more coming up, in many more projects for all kind of different robots. Maybe we have the human side robot coming up eventually, right? Maybe you get like a big dog.
We can do the hunt that you like. Okay, I'm gonna go and get your coffee, guys. Ask your questions. We're always here to help you. And you know what? Follow MEDIABOXENT on Amazon Live.
All right. So we continue with these great projects. Why you build, Dario? Can you show me what you're building? Yes, right on the side. Look, right there. Do you see that there? That nice picture? No, there. You see that? That's a little robot. We're gonna put it together. Okay. And let's go forward. Like I said before, in part 1, they have this is breaking down in listen, right? 1, 2, 3, 4. So we're going to introduce 2. So we left it the 1. So I think we did 2 already. I think we did 2. Let's look for it. No, we didn't do 2 yet. So part 2. Okay. the Adeept pixel drive board. So this is the main brain. This is everything, right? So this is the brain of this thing. So you get the Hexapod robot, you will need to see the board, right? Which it has, with the name on it, print called the Adeept pixel LED. And I have it right over here, so we can all pick it together. And that's the nice board. Okay, so we have it here. A very important part of the Hexapod robot. All right, yes, this is the main guy. There are many interfaces on this drive board. Which interface will connect with some of the sensor and electronic hardware modules. You can have many extension functions with Hexapod Spider robot product you need to use with the Arduino IDE. But first, we need to learn about the board. So let's look at the board. Reset switch, micro USB switch, 24 volts, ultrasonic connection, Wi-Fi, USB, Bluetooth. They upload running one, so it means that if you're gonna connect to Wi-Fi, you're gonna connect the hard. And the MPU 650, that's the one that sensors when it's moving left or right. That's a gyro. And the servo connections, right? Another MPU connection. This is a 5-volt out in the ultrasonic, and we'll look at the bottom of the board. So if I get the board here, man, I can smell the coffee. So that's exactly what we see. All right, let me get the camera a little closer. Get the camera much closer. All right, and this is the board. We said the switch, right? I think it says Bluetooth here, the Wi-Fi, right? The MPU, ultrasonic, 5 volts. No, power, not 5 volts, because it's like a 6 volt, whatever it is. I think 3.4 volts each battery. So we're looking 6-7 volts, and then here the 5 volt out, and I think that's just to power up some of the devices. And I think this one was the ultrasonic. Great, we had that going. All right. So here the WIN is the interface for the power supply, 6 to 24 volts. Switch on and off the code. Micro USB, the interface for the driver, the computing equipment, also the power supply to the board. So that's we connect here, right? What we have here, the 8212 pin interface for the module, 5 volts, the interface sensor for the MPU 650, servo port, ultrasonic, reachable, and Bluetooth, the Bluetooth interface, a global and global specification for wireless data and voice communication. We know what the Bluetooth is. So give you everything. Wi-Fi interface. You use the ESP8268 module. Yes, and it's to my wonderful guest here. This thing. So these have to be the gyro board. So if you look in these boards out, and I say, how do I know this one out? Because I can see the antenna. I see the antenna right there. Yeah, see, that's the antenna, and this have to be the gyro board. All right, these are two little boards we have here. Go back into what we get to put this together. See, they show you here. Oh, see, and this is the yes one. So let me see. So if you're gonna go Wi-Fi, it's either 0 or 1 state. So I think it's 0 it's Wi-Fi, and 1 if you're gonna be uploading. Okay, so good. We'll complete part 2. We're all on the same page. Okay, building the robot operation. It's like a tiny fun for me because it's so far. My manual is like a mile away. All right. Robot operations. Yeah, Arduino. So the Arduino work with the C and C++. Writing programming. Before you learn Arduino, you need to master C++ language or C++. And it's a complicated C language, right? So no worry. We don't need to learn that. We're going to be making this through an API, right? So we're going to use application programming interface. All right, into the Arduino library. So you don't need to worry about it. You're not going to need to learn any complicated C or C++. Okay. And then they give you the structure how the Arduino works, and I'm gonna go over for that. And then now we need to connect. So construct your Arduino. We need to get a ID, Arduino developer, and download it from the official site. So I'm going to click here. And boom, bop, we are here. And let's go and download this thing. Somewhere here should say downloads. All right. Time you got to look for this thing. Codes, what accessories, shield boards, not education, professional, and oh, you have cream?
Oh no.
Oh, it has cream?
Yeah.
Okay. All right, so let's see. I'm gonna open your window. Where to find download? Oh, okay. So store software. Okay, I see. I didn't look that. Looks a little different. All right, open new tab. Okay, chat here. Hey, what's going on, man? Everything is good here. Everything is not good. Well, the same. Everything is well. Everything is well. Not good. Good is not good. I say good. It's no good. All right. So how do we download this thing? Download. I need the download thing. Education. Maybe in education. Man. Oh, maybe here. How we download Arduino? What are you, Arduino? I said all cookies. What are you, Arduino? Go back here. After open, okay. Yeah, software. It's funny, right? There is not one that says software to download. You know? Do you guys see that? A professional, I don't think we need to go. Wow, they use that to cut the grass? No, joking. Okay. You know, I mean, if you got to download the software, can you put a tab where it says download? Make it simple and easy to find the download thing. Right? Should we something that says software? Huh? Yeah. Man. That beat me, this thing. I didn't find the download this thing. I need to download Arduino here. Why would we make it so complicated? I guess it changed whatever it shows here, you know. So let me search these things for it, because some reason is that cannot find it. All right, you know, I know who I'm going to ask for. Okay. All right. Hi, see, part of the education. You have to go. You got to go and ask Google for this. Okay. Now, okay, pre-installation ID software. Okay, download the Arduino. So yeah, not find it. I don't know why I could not find it before. All right, put it here.
You got it now, Murro.
Oh man,
Hello, Naldo. Welcome to
download page. So okay, so here the loose version. Get started. It's now that you have to download something and give you like you gotta go in and click it like a million pages. All right, window. Let me see. Download option. Give me the latest one. All right. Yes. All right. So instructions. Windows. Download my Arduino software. Download Arduino software. Man, you gotta click a million things. just to get download something. Is that loading now?
Ay, morro. You know what is funny? Also, I was organizing some stuff and going back and forth. And I hear you complaining here, and then I hear you complaining like a few seconds after on my phone. I'm like, what the flow?
Oh, man. Just trying to download something is like crazy.
Gosh. And then I just had even...
It's taking more time to download the Arduino software than actually build the Arduino. But it's funny thing, it's not downloading on me now. What I'm doing wrong.
Okay, send me the thing. Maybe I find it more.
No, I got it.
Has zero experience for that with that, but...
Okay, now. Okay.
Yes, yesterday was peace and today is chaos.
I'm downloading it now.
Welcome to MEDIABOXENT on Amazon Live.
I'm downloading. So guys, what we building today? Today we building this wonderful robot that you see right in the background.
And you can find it below on the carousel on the left or the right too.
Yeah, it's loads that. Let me see.
Get the robot or get chaos. Get this robot or get...
Yeah. So we're building this wonderful robot today, and this control with the Arduino, and this nice doesn't require you to get anything special. There's some projects you need to get Raspberry Pi 3 or 4. You need to get batteries. You need to get memory. And this one comes the whole thing. I think it's a great price. We're looking at $89.99. Now, what you guys seeing right now is happening every Saturday. Saturday afternoon after 1 o'clock Eastern time, every Saturday here on Amazon Live. We also multicast as well in other channels. And we put things together. And it's all based on STEM. Science, technology, engineering, and math.
Finally. Yeah.
And we can say A for art. It's part of art as well too. We can say art. And we love that. Why? Why is the reason we like so much STEMs? Because STEMs helps. It's going to help children's, everyone, especially for children's, because they help you to take the frustration or learn how to how to put things together, and eventually when you're an adult, we can handle things better right now in life. And I think that's what it is. You just learn, you get frustrated and you deal with the things. So it learns from a young age how to deal with things, put it together. And Menina and myself, we are super big into that. I wish I knew those things when I was just a little baby, whatever. But at that time, there was not something to put together, right? I don't know. People that thought about it, maybe. I don't know what it is. But and I think today is very important. It's part of education. It's electronics. It's tech, engineering. Kids growing up today to be simple. They know like an iPad, like nothing. It's 1 year old and running up. It's just part of the blood. Plus genetic becomes normal today. So it becomes normal. Why not make it a little more normal than that and get these things going? And what a nice thing to put things together and show that to the parents or show that to friends or anyone there, or just go and post in Facebook, Instagram, or whatever social network you're using up there today, and you just show to people, look what I did. And the enjoyment in the end, and I do have enjoyment that it's true in my case, is when I go and put things together. And I said, it's a frustration I have to deal with. Yes, a little bit I get pissed because, why is it not happening, or why I didn't read the instructions right? If they don't know, you see what happened? Yeah, I know. So now comes a 7-year-old kid and they said, Dario, I can do it faster than you. And I'm happy with that. I'm happy for that. They comes a 7 years old and can do it faster than me. But that's the thing. So that's why we have that great idea to get these type of shows here on Amazon every Saturday. I enjoyed it a lot. I really enjoyed it. It's something I like. I like electronics. That's what I did all my life. So I love to put these things together. Right? So it comes like those things I was a little kid. So why not do it now as a grown-up? Even more enjoyment to it. So I said there is no age for it. Anyone can put it together. So we bring different, I don't know how many we have already. Half a dozen of different robots. And we hoping we get more. I know right now we almost, I would say 2 months book of robots. So it's a lot of time. It's every Saturday. Projects can take between 1 to 2 Saturdays. Depends how we're doing it, how fast or how complicated things are. Right? So it all depends. So, but normally it takes about, 2 two great Saturdays to put this together. So just remember, MediaBoxenT here on Amazon, and we are live after 1 o'clock, and every Saturday just for this. Then normally time, Meninas in the mornings. You can catch Meninas in the morning, early mornings. She has a decoration, a little bit of tech, home goods, and all that stuff. And then I come back myself with Menina on 5:30 Eastern time, Monday to Friday again. And that's not more tech, but maybe we got a little techie stuff for home in the mix, video games and all that. Again, it can be good. Decoration as well too. So it's a mix show. So this show is always a mix. We mix a lot of things together here to create a wonderful show. Okay, so let's get back into this. So I think this thing is already downloading because we look in the instructions. We need to follow the instructions, and I want to do the way this company show how to put things together. You can chat here. Okay, what we have here. I was confused. Never mind. Okay. Kelly. Okay. Let me know if you're confused or something, or if you are. Yeah, we are here to help you, Menina says. Yeah, she's doing something else in the background. She's organizing the warehouse, so imagine that. Julie, that's what she's doing. All right, so we download the software. And what I'm going to do, I'm going to install the Arduino software here. And we go back into what we're supposed to do here. And this will be normally the normal installation, right? So here to tell you what we need to do. We did download there. It's under education. You guys, you need to look under education, and that's what there is not I didn't install a software, something that says software. You know what I did? I just went and typed. Okay, download Arduino, and I didn't send me, Google sent me to the right link because I couldn't find it in the main page. So here tell you, all the stuff in simple, and we need to install that. So we're going to do that right now. I think this is all like the installation of this thing. The menu bar. So let's stop there for a second. I did install this software a while ago when I did some projects, and then when I rebuilt this computer, I never put it back. If you guys wonder what I'm going to be building, you see down the corner. So we install the software. I guess what it seems to be like they break it down first, learn how to control this, and then as we go, we're going to start putting together. Now, in what part of that, I'm not sure. I guess I only reviewed 3 or 4 parts. That's it, not much. So I'm doing this actually right now, real time. We're putting together as we go. All right. Yes, we need to install some drivers. Yes, in case that's going to connect like the COM port and USB. Yes, we need to install the Arduino drivers as well too. Yes. So yes to everything. So we need to, okay, so that's completed. That's done. And let's load the Arduino. All right. We allow that. Java. Need to do that. And that's it. Exactly the first code page. Let's open this a little bit. And now we have the Arduino. And if we look at the instructions, I'm going to bring back the instructions. That's exactly what it shows here. Okay, file and the keyword. Okay, edit function to show you the code. Okay, so let's see, edit. Let's go here. Let's see, file, that, edit. All right, and that, simple. Okay. Again, they show you here in such way that you never saw an Arduino. You never worked with this before. So that's why, that's the base idea of what I'm showing you guys right now. All right. If you guys are in advanced mode, then you can just fly to this real fast. But the idea of this is based on, I never played with Arduino. No idea what the Arduino is. I don't know how to open a file. So that's why they did it this way. And I think it's perfect fine. Because that's the idea. When I read the instructions in the beginning, it says yes. Introduction to robotics. Maybe this is a good project to start off. And that much is in it's all the project that much is in this. Okay, so included library can be low after selecting library files and review the head file automatically and into the code. Yeah, so stretch, yes, and we can verify the upload. So let's see. Include library, robot control, but I don't think it's there yet. So let's see. So that we need to look. So I need to go to that library, and we don't have that robot control because oh yeah, let me see, robot control. All right, so that's the code for robot control. Okay, so the board and parted pools used in tools. Okay, tools. All right. Now the board can choose a different environmental board, and you can, okay, course you use for Arduino Uno. And now we need to use Arduino Uno to the list to contain many Arduinos available boards, modules. We can choose the correct one according to the module, right? Because there are different Arduinos. So let's choose Arduino Uno. So go to tool, board, Arduino Uno. See, you got Arduino Mega. These all the also many Arduinos. Arduino Yen. Okay, so Arduino Uno is select. We select anyway, but we reselect it. Arduino Uno. So we did that. Okay, the port can be used for Arduino and IDE download program for this. All right. So let's look at the COM port. Tool. Hold on. What we see that tools port. Tools. No ports activated. Oh, but I have to reset computer. Okay, no ports activated. Okay, why is that? Okay, the boards are displaying each port are different when the Arduino Uno is connected to the computer and display COM port 3. Okay. Oh, okay. I'm not connected. Fine. All right, see, I'm confused here. So when you are connected, when I'm connected to Arduino, I should be able to see that. All right, but I'm not connected. So I think if I connect this with the USB, we're going to see that. But it doesn't tell me to connect it yet. All right. And then you have the verification, check the compile. Yes, this is going to check when you upload the software, upload the code to the Arduino. Yes, when we create the code here, we can upload to the Arduino code. The difference with the Arduino, because I got the questions, and it says, what is the difference between the Arduino and the Raspberry Pi? Well, the Raspberry Pi is a mini computer. It's a computer. Call it mini, big. It's a computer. Simple as that. Runs in a Linux version. And it's a computer, so you can do many things. Whatever you put in the program, you can execute and run programs, multitask programs. You can run many things as long as you got enough memory. Now, on the Arduino, it's different. It's a reprogram board. So you create the code, you verify the code is fine, and then you send the information to that. And whatever it is, right? Whatever it needs to do. Turn on LED light, do this. Wait for the signal from the Wi-Fi. When you do this, turn the wheel on, turn the wheel off. So it's a pre-program. Whatever is done there. How you change it? Well, you rewrite it and you change it again. Come with the Raspberry Pi, right? You can change on the fly. You can do these things. You need to reprogram this. So imagine it's a board that allows you to reprogram. I think that's the benefits of the Arduino. Can you combine the Arduino with the Raspberry? There are projects where it does require both, right? There are bigger projects. Maybe the Arduino will do something else. The Arduino maybe takes temperature. Use boards. Okay, check temperature. Or use the Arduino to turn off lights or LEDs or measure the air quality. I don't know. And then send the information to the Raspberry Pi, we'll do something else. All right, so there's Arduino. Okay, save the code and cancel. Okay, in the computer. All right, yeah. Let's compare complex than the Pi. It's a little different. No. I think it maybe looks a little, but no. Because I thought you just follow the chat. Just follow the screen to tell you what to do. And that's it. Now, if you want to do something for yourself, maybe you gotta understand. I don't know anything about C++, but if you know C++, if you know Python or whatever, you can do just things here. But it's, the good thing that it's showing up there, so we don't need to go crazy, right? They give you basic instructions so you understand what we're doing. Okay, so installation the CR cell drivers. Okay, open the Arduino and you will see the serial port not acceptable. Yes, we saw that, right? When I go here, there is no port number. Yeah, because I'm not even installed yet. All right, so how we do that? So you need to find, and the folder provides by the Acceptance Hexapod leg expired robot and Arduino. So 02 software installation package, you will find the drivers and the folder, open it for Windows system. So by the way, this is all Windows. So then you can double click them and open that and execute that. So let's do that.
He's dragging bag like he's dragging.
Oh, but it's a big bag. Yeah, I know. Amazon, when every time comes here, comes with a humongous bag. You ever see the guys with bags?
They're like a big box. Like
yeah, that's just, what is that? This is like what do they call it? The second warehouse, the field center. Yeah, this is like a second warehouse. Okay, so let's go there and let's get a. Huh? No, I made a mistake. I went this morning to buy heavy cream, and I bought like fat free. Which I'm gonna throw in the garbage. I had to go to the store and buy. Man, I was so pissed. I said, it's funny because I got this thing, the milk frosted, and I said, when I put the milk, it looks a little weird. And look at the milk frosted, and I said to me, the milk is bad. Why?
it's bad.
Why this thing is not coming up with anything, which is not phone coming up? I mean, I said you bought a 5 free. And when I look, it says fat free. Man. So that's why it looks that way, the coffee. It looks like water. It looks like I'm drinking water. Coffee with water. Yeah, coffee has water, but no, man. I need to get cream. That's because I was too fast buying. I just grab whatever. Oh, half and half. And I was going to grab cream as well too, but I don't know why. So let me get him the half. And the good thing that I didn't buy more, I said buy a few of those. Imagine that, buy a few of those will be. Well, then I had to go back and return it to the store. So software-wise, that's weird. Tell me about it. Okay. Drivers. Aptech drivers. Okay, that's a Windows driver. I'll say, okay. So, Mac, Linux, Android. So they have all the drivers here for every operating system you need to install. Okay. So let's go install this on Windows. This is the drivers. And let's install those drivers. And drivers are installed. Okay, we did that. And yes, we execute that. And the drivers installed. Now I click OK. Installation. Okay. And now let's see, we got COM5. Or can be other ports. Let's see. Let's go back here. Maybe we need to reset this up. I'm not sure. Okay, doesn't show that. So let's quick Arduino here. And you want to save our no. Let's start this up. Let's open this again. Let's go into that. Make sure we set the top Arduino there. Okay, Arduino Uno. Yeah, it's gonna show me port. I think it's gonna show me port when I plug it into the computer. That's what I'm thinking. Okay, library. Hold on. I need to click robot. Okay. What is robot control? Okay. Robot control. Still not port showing. Okay. That's okay. Let's see what happened. Why didn't show ports? I think I'm not going to reset the computer now. Now you find the Arduino port and configure the different port. It means it's to pick a little bit. Okay. Connected to. Okay. Okay. So let's connect. You know what? Let me connect the Arduino board into the computer. Because I think if we're gonna do that, it's not gonna work. It had to be that way. I don't think I need to apply voltage to this, just for that. So, okay, so what I'm doing now, guys, I'm gonna plug this into my computer. Let me see. I have to apply voltage to this. Maybe it powered out through the 5 volts. I'm not sure. Okay, yes. A power up to the 5 volts. So on and off. There's no on and off here. Did we see the drivers come up? All right, just so I hear the speaker. All right. Yep, I got it. So very important. I just hear my USB going crazy. Okay, so very important. Yes, you need to plug it in. I don't, maybe I mixed up on the instructions, but in this case, it's COM3. It can be COM5. Depends on the computer, right? COM3. So we activate that. So now I can talk to this thing. So I'm powered in. I'm powered in just my computer through USB, and right now through the 5-volt power of the Arduino board. So now we can upload, config this thing, or whatever we need to do next. So normally all these projects first goes into the software, and then you build it. And it's kind of nice because that way you have all ready, and then you press a button and start. The other way around, you finish your project and say, oh man, now I have to go to the software. All right, so we have that. Okay, in my case it's 3. That's fine. Can be other numbers. Okay, now you need to find Arduino 1.5 folder. Oh, okay, so that's okay. So hold on, this is hold on. Just one up a little bit. Now to find the Arduino serial port. Okay, and the computer config to different port. That means to pin below the board. It's been successful connect to the computer. You will need to pay attention to this corresponding step to the follow course. Yes. All right. This is the solution after the Arduino cannot be opened. Okay. We don't need to do that. Okay. All right. I guess this is not open. I don't know if that. Okay. 6. I guess I got to do 7 as well too. Maybe. Okay. So before using the FX Spy Robot, you need to configure library. Find on the downloads Arduino directories, IDE directory. You will need to find the folder provided by AppStack. And let's look that. Let's go back. And I think I saw it. Libraries here. Right? Yes. Libraries there. I guess we gotta maybe couple of those things. Okay. We do that. Hexapod. All right. Oh, Hexapod. And yeah. Oh, see the pi there. So, okay. So, Hexapod. Yes. Now, you need to copy files. And Adam through Neo Pixel and Anna Jackson. Oh, okay. So, just copy the whole. Let me see. Servo copy all those file directories on the Arduino IDE installation directory. It shows in the configuration. Ooh, all right. So when you copy that, then paste the full folders and the library as it shows. You want me to move everything, or you want me just to move Hexapod? Oh, okay. Then Servo and then that. Oh, Servo and AC4. Okay, I got it. And that. Okay. So I need to find the. I need to find that. All right. So hold on. Let me see where to find that first. Hold on. Give me a second. Because I don't know where it's going to send me my computer. I think I should be in Windows Directory Programs. Where we find that? Where we need to find that now? Doesn't tell me where to find that. Okay. So should be Arduino call? Let's see. The Arduino software. No. So let's look on programs, files. Programs 86. Maybe. Arduino. Yes. Okay. Yes. So to be able to, by the way, to do this part, you guys will have to find Arduino in program file x86, and then you look at Arduino, and then there we have this. So we look in the structure of the, see in the directories of Arduino. So I'm going to click on libraries because that's what they want me to do. All right, and we see Servo. So what we need to do here, if I move this to the side, so we need to copy first the Hexapod. You need to copy all the files, Adam Fruit, Adam Jackson, Hexapod, and Servo, and fill all the copies and files into the library. So should be one called Adam Fruit. Yeah, but I don't think I see that on the other directory. All right, so let's see here. Let's see here what we have. So software installation, library, S4. All right, Servo, and what we have here, how that works. Servo. Okay, let's go for it. I'm gonna click Servo, and it's go Servo on Servo. All right. Yes. Replace all the files. Continue. We replace that. Then S4. We have an X4 here. So we have Hexapod. That's Adam Fruit, but okay, you need to copy all these files on Adam Fruit. Okay. Servo 4, copy all the files into the library. So what I'm thinking, if I understand this right, I gotta grab this thing and copy here. And then what I copy S4. Oh, just S4 there. Oh, you need to copy all the files. Because I don't have that. Okay, I don't and Hexapod, Servo, S4, all the files into the library under Arduino. Installation as it shows. Okay, maybe, you know what? What I'm going to do too, just in case. Let's do this. Oh, maybe I did it wrong. Okay, let's do this. Oh, we just move everything. Okay. All right, let's do that. All right, let's see what happened. Maybe I did it wrong. All right, that's good for now. Okay. Okay, and we complete with that. So let's look at the next one. So what part we are now? We are in 3. Okay, so we'll complete 3. Let's check it out 4. Let's see what happens. Let's see if this thing works. 4. All right. Okay, so this will learn how to connect the servo. So compile this list. So we need the board. Check the chat. Okay. Oh, okay. Yeah. Yeah. Let's clean the other boards. It's a different instructions. I know what you mean. The instructions are, man, I gotta get cream. Thing is like drinking water right now. So I gotta get the servo here. I have one servo here in my hand, the board and the cable. All right. Different instruction now though. We're saying a little more, takes a little more time, but we already built all the stuff from this company. Okay. this particular, that's why they did it, because the idea is they want to introduce one. I guess if you never built one of these things, how to do it. That's why maybe it looks a little now more complicated, a little more messy in a way, but I don't think so. But let's see what happens. I don't know. I got to see and to get to actually to put things together, because it looks like not put things together yet. Okay. So introduce the servo motor. Servo motor refers to an engine that controls mechanical components operations of the servo system. And this kind of auxiliary motor indicating transmission device. This motor, right, is a gear motor, and that can rotate only 180 degrees by the controller by the sending pulse from the microcontroller and then pulse the server in the multi-servo motor. It includes a housing circuit and non-core motor and gears. Yes, that's the gears. So it allows you to send a signal, a pulse to this, and you can move 180 degrees. Show you the parts with that. Principles of how this thing works. There's a lot to read here. Okay, let's skip a little bit. The servo mechanic is an automatic control system. They enable objects, position, orientation, state, and other output controllers quality to follow and change the inputs and targets and value. So technically we send information and this will move in, move out. The driver board sends an PWM signal to the server, to the AC circuit, and the board and the signal calculate the rotation direction of the drive motor and the transmission to drive forward and swing the arm. And that's really what we see in lately. So here they show you, right? Oh, okay, the pulse is also pretty interesting. So the pulse frequency is 50 hertz. So it's if the 50 hertz, the pulse is every 5 milliseconds, that means 0 degree. If it's a pulse every 50 hertz on 1 millisecond, keep at 45. That's why it always keep at 45, because now it sends a pulse at 50 hertz every millisecond. That means keep at 45, keep at 45, keep at 45. Pretty interesting, right? 1.5 milliseconds at 90, 2 milliseconds 135, and 2 milliseconds at 180. So if you have a pulse that sends to the AC chip that is 50 hertz every 2.5 second interval, what you get is this will keep it up all the time at 180. The principle of writing functions, right? The program used to write functions to control and rotation the server, for instance the server. So this one again, I don't go over everything, right? But this one is like principles of everything. So this is a little different than the other robots we build. This one is like, I don't know anything, I need to learn principles. It's pretty good because show you how the server works. So now you know, okay, how the thing knows how to do 45. So it's a 50 hertz signal. Components, yes, every time you get that. They're bigger, smaller, all kind of time, right? So you got the ground or the plus minus, and one is the signal, right? One it sends the signal to the board. The signal, like every 1 millisecond, keep at 0 degree. Every millisecond, keep at 0. Every 2.5 milliseconds, keep it at 180. So we need to control it there, right? So how we control this? So we open Arduino software as I show below. So let's connect this. All right. And I don't know if you guys are showing that what I was talking or not. Did I show you guys? I don't know. I think I had that screen and I forgot to show you what I was seeing. Hold on. I think maybe I forgot to change the screen. But this is what I'm talking about. Okay. I don't know if I show you guys or not, because sometimes what I see on my screen is not what I'm showing to you. All right. That the parts we see in the servo. All right, and what they call the MPWM signal. All right, and that's what it controls the degrees of these arms of the little motor plus gas gears, and that's what it keeps it all the time at 45. All right, parts always includes that. How we're going to control this is by controlling to the board. So you only need to connect one number 2. So let's look at this one. Yes. So we look here, AD002. They are different models. All right. So we're going to connect it here. So it's funny because they show you, so yellow. So if you see it right over there, right? So we need to follow. You need to follow. So yellow is the one in the back. If you put it backwards, you kill this thing. So this goes that way. So yellow is the one in the back. So we're gonna plug this up. There's no yellow, by the way. It's orange here. Very nice show. Thank you. Yeah, that's why I went over back again. I was just talking. So the yellow is not yellow. Normally it's a yellow or orange. Okay, guys. So orange. So we're gonna put this here. I think that move for a second. Yeah. So up. Because the way we see it there, a little different, but that's the way we can connect this. All right. Remember, and it's always orange, not yellow. I know show you yellow in these programs, but. All right, so we need to open the Arduino software, and let's do this. Let's do that, and let's open that, and let's find that thing out. All right, let's go for it. So make sure we are connected, and we are already connected. We are Arduino 1. We are that. So we're gonna go in open. Library. What shows that only? Okay, Uno. Oh, I see. Because okay. So there is one on. Okay, so I see what happens here. Oh man, they are on my. It's not on. Okay, it's in documents. Yeah, that can be. Yes, it was not in there. It was in the documents once. All right. See, they should show you that. They didn't show that it was supposed to be in the documents. So you didn't have to copy it. Oh, it's fine. They didn't find it there, but it should be okay. So what I need to do is grab another copy because I just moved the file there. Okay. So you need to go into your document files and copy there everything. That's what they do. I don't know why they didn't say that, but I thought we'll have to go into the C++ and find it there. All right, so hold on here. Robots. 6 like Aspire. Okay, course, software installation, and library. I'm going to just copy the whole library directory into my documents. Give me a second. I'll be there with you guys. Arduino. And that should be it. Change the screen now. So now if we're looking, if you go there, that's it. So if you got to do an installation, you find it on the document. That says what install. Yeah, they make it's illogical because you're going to be writing programs there. So you don't need to look for your programs x86 files, okay? Just documents. Yes, that's one installed in mine, and I think that's when it's going to install on your computer. So I think now, if I go open, and I go open here, and automatic go library, we see that. See server, and let me see, that's the file. That's the file here, and INO. Oh, look into. Oh, listen for is there. Okay, confused here. So desktop. Is it listen for? Okay, course. So for installation. They're not inside there. Why you show me that? Let's go back. Let's rewind this. Let's take a step back. Okay. Provide open. Open listen for folder and select. Not there. It's not going to be there. gotta be there. Oh. Okay. Core score. Okay. It's different. Different. I show you that here. Hold on. Let's let me rewind a little bit here. Show me that. Maybe I skipped some what I was reading. Find the folder Hexapod Spark Kit. Okay. Okay, Spark Kit for the Arduino. Course 3. Okay, course core. All right. Let's open files. And course core. Okay. Okay, I was wrong. I'm always wrong. Okay, course core. Listen 1 server, and now we got it. Now we can close because we don't need that one. Opens a new one. Make sure this new one is talking to Arduino Uno and it's talking to Campo 4. Okay. Yeah, by the way, when you open, it's going to open a new window. That's why I closed the previous one from the Arduino. Okay. All right. So, and after you open, and click upload. All right. Upload. Oh, well, we got to see how they set up this, the little key. Okay, let's see what happened. Upload. All right, it's uploading. Yes. So hold on. Oh, sorry guys, didn't show you that. Okay, so we got a problem here. Let's see what's going on. Okay, invalid library found on the C program Arduino. Okay, no headed file found on Arduino. Okay. Okay. C user. Okay. Oh, this thing is on. Okay. Well, it says go, but this thing is on. It's moving. Oh, you're gonna hear. Oh, yeah, you hear it? Okay, let's see what happened. Supposed to do that or now. All right, so upload. After upload. Okay. Then give me that. You click again and upload the code. Okay. Code program and second function, degrees. Okay. Okay. Okay, and then what happened now? Okay, this keeps going like crazy right now. All right. Let's look at the code. What this code will do. Okay. It gets to 15 degrees. Wait a second. Then go back to the degrees. Oh, yes. Wait a second. And then go back. And that's what it's doing right now. Exactly. So we execute that. Give me the error, but I don't know what. But that's what it's doing. Yes, I can feel that seconds. So what we did, I think it's moving now. And I don't know how to stop this. Hold on. Let me unplug it because I want to show you that. Let me get one of these things because I think it makes more sense to put one of these things. And so in a way, right, it's pretty simple because you can just write your code there, right? Put the information on, right? Simple, plain English, right? How many seconds you want things to move. Right, so on the case of this program that we running right now, all right, hope you guys can see. I'm not sure this is big enough or what. For me, it's small, but I don't know if I can make this. Can I make the fonts a little bigger here? Can we make this? Can we make this bigger? Hold on, Control plus. Do this bigger. Thank you. Okay. So we run the code to this, and we're gonna say that 180, 15 degrees, then wait, right? Then wait 30 degrees, wait another second, and then 45. That's exactly what we're going to be doing now. So if I change this, we already upload the code. So when this comes on, it's going to do that. Okay, the code is already part of the software. So yeah, see? All right. So wait a second, go that. Okay. That's it. That's the difference between the Arduino and the Raspberry Pi. They technically, I just upload the code, turn it on, and execute the code. It's a bunch of if the code is different ones. All right. So exactly. Yeah. Okay. So it's good. We learn now how to do that. All right. And yes. So perfect. Here, loop option to control the servo and angles. Okay, so we complete that part. Let's go for this one. We don't need anymore. So now let's go back and let's go to the next part of the course. So we did servo control motors. Okay, now making some lights. All right. So now using the WS2812 to make the lights. And this lesson we'll learn how to use the WS8212 RGB LED. Wow, RGB module in colorful lights can be changed to various colors. So it requires the same board we'll be using, requires the micro USB cable. We plug it in a jumper cable with the light. So let's go for those items. So I know the LED light is run here in the Pandora box here. So we have here this, because that's the light. And I think no jumper cable required because it's already here, I think. Maybe jumper cable. Let's see what else. And oh yeah, but it's already included the jumper cable. It's already in. Okay, it's already in into this. So we have the board. We leave that connected. We can disconnect. I think we're not going to use that right now. So we take these out. And this is the LED. So we're going to control LED. We learn how to turn on and off LEDs. Okay. All right. So there's it. Okay. So this module is low power RGB 3-color lamp, which can control with the chip. Appears on the same 5050 LED lamp. It's the same ones they use. Yeah, this type of the ones you see, like those big strip lights. Elements on the pixel. The pixel connects to intelligent digital interface data, leach signal, and let me see the circuit. The high precision color. It's a 12-volt high voltage programming control panel. Okay. The principles. The RGB module is a low and a color lamp integrated with oriented control chip. Appears the same as the 5050 LED lamps. Each element is a pixel. Right, so each light has a control as a pixel. Each is one of these things. Again, and you can use high voltage. So the data protocol is a single wire return to 0, right? Because in reality there is 3 wires. So we have a ground, minus, and plus, and the other one has to be the signal. It has to be that way. So the data control is a single wire to return to 0. The code illuminate methods. After the pixel is powered on, resets. So the dim terminal accepts the data transmission from the controller. The first 24-bit data seems to and extracted by the first pixel to send to the pixel. After the remaining data, it shares with the application by internal shipping process circuits that remaining data forward on output to the next pixel or the port. Okay. So the first parameter is set pre-color. Okay, that's the code to LED. Numbers, pin 0. Oh, pin is 0. The color defines to the color pixel, represent to the brightness level of red, green, and blue. 0 is the darkest 255 to maximum brightness. It needs to use a strip. Okay, color times 2 that. All right. So that connects right there. So that's what it is. I know we're building a robot, but I like to follow what it's supposed to do. Okay, we can just move along and just put this thing. But this thing is supposed to be this way. So that's why I said it's going to be a few sides here, putting this together. All right, so we got that. Okay. I think this is pretty interesting. All right, so we learned a little bit here on Amazon. Right. Good class today on microchips and robotics. All right, we're gonna put this nice thing together, and we coming up more. Maybe some more complicated, some less complicated. Man. All right. Okay, so we got that. We plug it in, and we need time to run this thing. Okay, how to connect it? We connect to the Pixel. Run the code program. For this lesson, you need to use the micro USB to connect, and we're going to use that. We need to open again the Arduino IDE software. We're going to connect the Uno. We did, should we default that? COM5 and -3. Be aware of that. Should be already there. All right, we're going to open that. And we're going to go to lesson 5. Course lesson 5. And we're going to open that. All right, let's do that. Let's clean up the screen a little bit. Let's bring this down. Right, and let's go and open. All right. Let me try for my desktop because I got it on my desktop. Let's go into that. And course code. And why you said number 6? It's ultrasonic. That'll be 5. I thought it was 6. Okay, 5. All right, we got it. We can close the previous one. The previous one was for the server. Remember, servo. We don't need that anymore. So we have this. So the logic for this. So let's read this up a little bit. Let's check the code. So color value random. Okay, random. Okay. So red 0,256. So I think it's going to go brightness to 256. I'm going to change colors. And which lamp? Okay, RGB, then red, then green, then value. Okay. Then goes back. Okay, let's see. Delay 50 seconds. So let's see. I'm going to upload the code. So what happened now, I'm going to delete the previous code. I'm going to plug it in, by the way. So I forgot to do that. I got to do this again. Plug it in again. So what's going to happen now? We're going to be deleting the previous code. Okay, so remember we sent the server one, so we're going to delete that one now. Eventually, you need a whole entire code to do everything, but we're going to delete that now. So unplug it in. Go back. And let's see, tools. We are connected COM3. We are in Arduino 1. And Arduino 1. Now we need to upload this to the control board. Okay, so it's uploading. Okay, gives me an error right there, but yes, we're back. And now we upload the code. So now let's change in all the colors, see? And because it says 255, so it's the brightness here. Okay, initial begin the strip, 255, brightness, okay. So set the brightness to initially 50. Oh, that's why it goes down. Then avoid loop. Get the colors value random. 0 to 55, 0 to 55, 0 to 55. So green, and blue to 55. So brightness is 50 actually. It's not 100. We can actually change the code. Let's try that. So 0 to 255. So it goes to all the reds, all the greens, and all the blue. And that's why we got all these colors. It's not a 100%. So if I I know much about this. If I go here and I say 100, right? This should get much brightness. So let's re-upload the code. And let's change cameras right away. Meanwhile, that thing is uploading. And yes, much brighter. You notice that what happened now? Now I'm gonna go and change the brightness to 10. And I'm gonna re-upload to the Arduino board. Upload. You see that? It stops for a second. It's pretty cool, right? So that's a nice thing about the Arduino. We can upload one single code on straight a bunch of codes, and as soon as you turn it on, turn it off, it starts. It's not like a Raspberry Pi that needs to read the information out. Now again, this one runs multiple codes. The other one is it's a computer. Okay, it's two different things. If you're gonna run something, you can run an Arduino now like a temperature control board. You can run like a strip LED lights. You can do all those things with this. All right, so good. I like this. I know, like I said, Nando was saying, looks a little more complicated and not as clear. The other one, I think the other one was more straight to put it together, and I said this one, at least where you build it, you know why changing colors. Why is this happen? Why it's changing colors? So now you know, and you can, when you get the main code, I'm sure we can change things around. But now we know. So in reality, if you want to build in a strip lights with colors and all that, you can get an Arduino board, Arduino Uno, get a bunch of strip lights and do kind of this way, right? So we'll be back here. Okay, and the information provides, yeah, let's empty code and open that. We did that. And the main code, right? Now about the principal operation, you must verify and curious how to use C language to program W82C module on the Pixel drive board. So the instruction is how the main code is implemented. Okay. And then here, like we saw there, that's the main code to do that. All right. And now we complete that one out. So let's move to the next one. Okay. Main lights, ultrasonic value. So I guess in this one, we're going to learn how to do that. So let's unplug this. Let's remove the LED light. We no longer need that. And we need to get the ultrasound board. There it was somewhere here. Okay, this. We need this one. Yes, we're going to need the cable to connect this up. I don't need this specs for now. There has to be cable for that. And got to be this one. All right. So we're going to be connecting this out here. Just want to check something here. Okay, VCC. Well, this one. Give me VCC here. No. So should be straight anyway. So all right. So what I did now, I connect these two boards in. Okay. Change the screens now, and we go back into the board here, and now we see, all right, the ultrasonic board. So I believe the ultrasonic distance sensor. So this is an instance. The major ultrasonic sensor is using HC-S404. The top of chip. Components of two left and right probe. Yes, most likely the human eyes. One probe responds to transmits a sound wave for detection, and the other probe is to receive the sound wave. Yes. Oh, thank you for following. Let me see. Burning. Thank you to follow MEDIABOXENT. All right. So, and yes, one is a transmitter and one's a receiver. It's just like sonar, like a submarine, right? You sends a pin out, and then when it comes back, how long it takes the pin to send out? It takes 1 second. 1 second or 3 seconds equals to 1 meter, 10 inches. All right, so the distance is equals how long it takes to receive back and forth. Transmit to sound waves and detection, and the probe responds to the sound wave when it returns. It uses a 4-pin, so it has a VCC, so it's the voltage, right? And the trigger control and input, or the echo receiver, right? So the echo is the receiver, and the trigger one is one that sends out. And the ground. That's what it's for. So you got plus, you got minus, receiving, transmit. And that's what it looks like. It works principles. Again, detection the distance ultrasonic wave. It calls echo detection method, which ultrasonic emits in the direction of the moment in time to start in the same, right, like I said before. Whatever it takes to go back, ultrasonic wave air runs in an object, the way into your face, and the object is black, and reflect the mirror back, and then receive it by that, and then you calculate. And this is the calculation here. So seconds equals to 340 feet divided by 2, because that's what it gives you, like the formula to figure out how long this thing out. And we have it here. Barrier, right? And we see that. Receive, transmit, how long it takes. All right, so we're going to be connecting this guy. How to read the values in ultrasonic. We're going to use Arduino again. So that's we're going to use the C language to learn how to read the values in ultrasonic distance sensor. We run the code, right? And let's go again. Again, some way. Make sure you are on Arduino 1. Should be always Arduino 1 when we load up for the first time. Should be all connected to port 3. My guess is port 3. Okay, I'm going to plug it in so we can read that in a second. All right. And port 3. And we need to find the directory for that robot, right? Ultrasonic. We're going to open that file. When it's done, we're going to upload that. All right. And we're going to check the code, right? And baud rate 600. Okay, so let's see that, and then we should get that. Okay, so let's go for it. So we're gonna open this one. We're gonna close in a second. No longer be available for us. So we open this up. We're gonna go up once again, and we look in the ultrasonic, and that's the code. And we'll see it. So we see that. Let me move that into the side a little bit. All right. And okay, so input echo, so baud rate connects there. Okay, print the message temp. Okay. Oh, print trigger, temperature, serial motion. All right, and this is okay. All right, so let's activate this. Well, what we're gonna do, we're gonna upload to the board. So it's uploading. So that's uploaded already. So, but there's no physical thing I can see here right now. So we need to load this to serial monitor. And we got it. So now let's measure whatever. So I'm going to put my hand here. And it's 15 centimeters for that. I'm going to put the hand close. And now we got 4 centimeters from the distance of that. So how do I do that? This way. So I have this, and I put that here. I should be, let me use something else because I can use this. So that should be about 4 centimeters, something that way. That's 4 centimeters. That was a good guess. 4 centimeters. And we see there, again, 3 or 4 centimeters. I'm going to move this a little far now, 8 centimeters, right? 13 centimeters. So what happened? What we're doing right now, we saw in an ultrasonic sound, and maybe Kat or Doc can hear that. So one of this one is the transmitter and actually receiver. It says an R here and T for transmitter. So what happened there? This sends a pin out. Just on a pin, ping. All right, and then comes back. Okay, so how long it take this? When I send it out, and went back to 1 millisecond. Okay, so then you have to do the formula. 1 millisecond equals to what? And then this thing can show you. It show you that. Good, right? We should change it the name Run Some Code today. The name of the show. All right. Actually, I had fun with this. It's fun. All right. We finished that part, and I think we are good here. We close this up, and let's see what we got here. Yes. Baud rate, they got baud rate fine. Let me see. It should be fine. It was already connected. 9600? Yeah, 9600 baud rate. Okay. I use a serial port for that. All right. Main program or make code. We see that. See, set the connection on the pin echo. Yeah, pin receive that for the trigger, and open the serial port data baud rate 9600. And give you here the code. And we finish with this listen. All right. Let's go back to the next one. 7. And I think this has to be the one that detects a move. All right. So we're going to open this a little higher so you guys can follow a little bit. All right. In this case, we're going to look how to read the data from the MPU 650. Let me turn this off. We're going to take this off. I don't need that. So we need to find that. I'm going to need to find the little guy here. It has to be this one now. And that's the board. Okay, that's the board. Yeah, maybe we should get more pressure like this. It's good to learn. Okay, so we need a board. We need a cable. We already plug in, right? An introduction to the MPU 650. The MPU 650 is the world's first integrated 6-axle motion tracking device. Very interesting, right? Integrates a 3-axle, means in a gyroscope. Think about it, right, for the second, right? It's like the chip itself is a gyroscope. How technology got so crazy, right? People think you have the moving parts. Whatever, I don't know really how in the chip that this works, but let's look at this. Imagine this, right? Gyroscope, right there. Well, same technology you have in your phone, but all right. So this is 3-axle in a accelerometer too. To explain digital motion process, DMP, digital motion processor. That's what it calls that little thing there, man. Imagine that. 20 years ago, it was not impossible to do something that way. Okay. So digital motion, which can connect a third-party digital sensors such as magnetometer. I don't know what is that. Or in I2C interface after the spatial board 9 pixel. Okay, axle through I2 and SP. Okay, interface only available on the MPU 6000 and 6060. Okay, we get a little. All right, so let's move a little forward. The gyroscope can measure an angular velocity and can measure acceleration, accuracy, track, and fast in a slow motion measure. And give you that how that works. Can measure range from plus or minus 250, plus 500, 1,000, and 2,000 degrees per second. The chip uses a 1024 byte FIFO. I think it first in, first out. I think it is. That's what it's for, right? I think it's first in, first out. Okay, to here reduce the power consumption and consumes all registered use of 400 kilohertz in I2C. Additional with temperature sensor and oscilloscope plus or minus vibration. Oh wow, that's crazy. Okay, and that's how much voltage. Okay, and that's what the chip looks like. Very interesting, right? We had to read the data. Now we need to know how and how to read.
Colorful cable.
You see that? So now we need to read the data from this. Right? The MPU 650, and we're going to run the code. Again, we connect to port 3 in my case, and we're going to run 7. We run the code, and we're going to open it there and be able to run the manual because there is nothing I can see there on this device. So we are connected. No, we didn't connect it yet. Let me connect it. All right, and this one should go here. So let's see where it goes cable. So hold on. How we connect this? I didn't pay attention how we're gonna connect it. Oh, so we need to get the little cable. We got that one. The battery. So let's see how many cables I got here. Oh, maybe this. All right, so how are we going to connect this? All right. Oh, okay. There. Was not looking to that. So we're moving too fast. Right there. So we need those 4 cables. So if I bring it here, I should bring the screen here. Hold on a second. Screen capture. On Windows screen capture. So what I'm gonna do, I'm gonna bring that a little smaller. Yes. Right, yeah. I'm gonna bring that screen so we can all see it together. I like that's the way. See if I can make this smaller a little bit for you again. We're not wasting space. Real estate is expensive here, so it's a joke. Alright. And that's what I want to do. Okay, so let's look. All right, so we're going to plug this in first. We get that in. And then let's follow that. So the first one is the green. So that's your, this may be a signal. All right. Then you plus 5. You minus. And then you see that. So data is green and yellow. Just like USB. All right. All right, we have it there. And we have it there. So I guess when I move this, it's going to give me different different readout. So I'm going to plug this again. Okay. This is on, but it's not going to give me any information there. I'll make sure we did this right. Yes. I thought there was another light there. Okay. It's not going to give me information because we need to run the code. So we're going to run the code. And we should get some values there. And we need to set 1250. All right. So let's go that. Let's run my next code. Ultrasonic. All right, let's kill the one in the background. I don't need that anymore. So we're gonna upload the new code. To the board. Oh, hold on, sorry. Yeah, right there. So it's uploading. I'm gonna make this a little smaller so you can see. So we upload the code. It shows right over here. So we're gonna go right here. We're gonna change this to, oh, you see that crazy? So let's go to baud rate 1250 there. Oh, scare me. Okay, and now we got it. So now, man, this thing I can read this information super fast. And so now, as I move this thing, right, it can calculate the speed. You see that, or the position of where this chip is at right now. So you can see the angle. Believe it, right? And you can see the angle and also the speed. When I move this thing up, I can calculate all that. And it's a gyro, so calculate left, right, whatever position I'm at. Codec. And if you see that running, actually we can see that running now. All right, we see that code changing all the time. All right, good info. Stop that now. We don't need that anymore. We complete that, and we're looking at the main screen again. We set that main code, right? We set the read 115200 to the manual there, and here to give you the explanation how the gyro works in loop format. All right, so calculate the X, Y, and Z axle data and the angle using the chip. All right, so we complete 7. Let's move to 8. All right, we're gonna unplug this up. We're gonna need. All right, we're gonna unplug this. All right, and so in this part, we're gonna learn like the module to establish wireless connection with the remote control servo. So we're gonna use in the next module. They have it somewhere there. Tiny guy here. So this module is in NA and ESP 8260 is an ultra low power, right? And UAR Wi-Fi transmitter module. This is a very compatible package design and ultra low energy consumption technology on the industry. Okay, so they use for the devices, they call it IoT applications for the smart devices. That's why they use that. All right. So the serial port transmission of PWM control to the input and output control port. The rate, that's a baud rate I can get. And a light, a tricolor LED light motor speed controller. All right, so let's see how this thing works. Okay, the support working module, all that. Okay, SATA module. Okay, API and so okay. So the wiring of this configuration, we're gonna wire that out and gonna put a servo. Okay, very interesting. Okay, so let's give me another servo here. There. So let's plug the servo again. Orange up. Then let's plug the module. Okay. Oh, this way. So you're not use that one out. Okay. Oh. But you still space it with the other one in? Okay, give me space for this. Okay, yes, space. All right. Okay, let's plug this little guy here. It has an LED light there. It's there. Okay. Program the code. Let's plug it in. Oh yeah, that light up over there. Yep, it's a blue light there. Okay. So once again, like before, and okay, so remote control servo. So install the Arduino, open and you need to turn into 0 to ROM 1 and switch board to 0 when upload the program into the board below. Okay. So well, first I need to upload it. So okay. So let's upload. Open. Yep. So. All right. Let's upload this. Here in the bottom, show you how long it takes. All right. So I think it's uploaded already. Okay. So now we need to change it to the position here on the side, a little tiny thing. And now it's in 1. You need to turn the and upload to 0 from 1. Switch over to position 0. Okay. When the position 0. Okay, then upload the program. Okay, oh, okay, so 0. Okay, so let's do it again. Let's upload it again. No, we have to upload. Okay. Did it? Give me an error there, but okay. Okay. Okay, 0 to 1. Okay. All right. After that, successfully IP module will generate a Wi-Fi hotspot, so you can check the ASP. Okay, and generates by. All right, so let's see if that actually sends out a signal. All right. See, that sends a signal out through the. What is supposed to call? Oh yeah, my ESP. Okay, I have it here. ESP 8266. 8266. Yes, I see it here. Okay. Then password for this is 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Connect. Ooh. Okay, I'm connected to the standing board here. All right, so I'm connected there. Okay, so I have a connection there. Now pay attention. Oh, yes. So how am I supposed to do this? Now using the other end, desktop. Okay, I can. Oh, you need to use an additional USB wireless network card, which is a desktop computer connected Wi-Fi. All right. Yeah, I can do that. Can we do that? No, I can't. You know why? Because then I will have to disconnect the whole network. I will have to disconnect everything if I do that. Oh, too bad. All right, so hold on a second. Let me see. Yeah, because it's not connected. It's just a local connection. Course, package installation, source code. Oh, yeah. Yeah, I see here. Just thinking how I can control this. That's a Python file. How do I use the Raspberry Pi? Oh, but I have to bring a robot to do that. Just thinking. Yeah, because the thing is, I'm not gonna be able to do that. Because I can see how to do that. Because I'm connected with my phone, so you need to connect with the computer, and then in reality with that, we should be able to control that. And IP address, yeah, give me the IP address, but because I'm just connected to that. What is IP address of this? I didn't have a connection with advanced. Yeah, 192.168.4. That, yeah. And I don't think can you reprogram this to be on my own network? Okay, let me look at the actually code for that program. Can we reprogram that? Can we put in a Wi-Fi there into it? Executes on one type of Wi-Fi. Okay, so here's what it is. Forward stop. Okay, so okay, password. Oh, I see here. We see that? My password protocol. Static IP address or yeah, because reset Wi-Fi, restart, connect to server. Yeah, and I'm not sure if I can enter like an on IP address here or something to be able to do it. Because if I can do that, then I can control the board. But can I do it through a computer? Because I will have to disconnect to every network. And I can only run this. Well, this one looks like it's a Python software. Yes. Yeah, that's because I have Python installed on my computer. That's why I'm able to do that. You know what? Let's do something crazy. Let's use my car. I think I can do it. Let's start. I just started my car there. One of the projects we did before. I'm gonna connect. But I gotta put the code there. I don't know if I can transfer files through this thing. I never used to transfer files. All right. So let's see. I'm thinking, because I know I can. Then how am I gonna handle that? I can't change it. I was thinking, okay, I connect to this, but then I will change. When I change IP address to this, I will not be able to connect. All right. So that one we stop it right there. Should work. The idea, if you guys gonna do that, if you're gonna do this, this part of the project, in reality, you will have to disconnect your network and then choose the network we did that. It's called my. If you look the code here, so it looks my, and my IP 286 here, 266. Right, it gives a dynamic protocol IP, and you can then connect. And it's there. I know it's working. Now through the software here, in reality, we can, through the Wi-Fi, we can control here and go, auto, left, go up, right. And we can control and control the servo from here. The idea is for that. But for me, I will have to disconnect over the network and lose all the connections. All right. So I think after that we complete that section there. I think it's pretty clear how this thing works. All right. Pretty clear. I'm gonna put that into the side, and let's see what else is that after that. I think maybe that completes all the understanding and how this works. All right. Then you connect, right, and you're gonna use this too. The other one, attack, reverse. This is all restore, forward and back. So you're gonna hear the servo running, forward or back or moving. Okay. All right. So okay, so control and okay, 90 degrees, or maybe we need to set all the legs of these things. Okay, so servo 90 degrees debugging. Okay, since the initial angle is the factory build servos will be different. You need to adjust the angle of the servos before assembling the robot, and all angles adjusted to a 90-degree angle. That's true, because it can be so when you put together the robot, or whatever robot you're gonna put together, you have to make sure it's always on the same angle, right? So we're gonna do that. We reset it. A lot of these things you're gonna do that. We're gonna reset this thing out. Okay, so for this you need to prepare 13 servos for the robot kit. Only one is connected to debugging at a time. Okay, so we need to find 13 of these little things. So here we have one. So let's take 13 out of the bags. And throw these bags out. Because then you finish with 1,000,000 bags of this. All right, so I'm going to get 13. So we'll be all the 13 legs for this guy. All right. And we're going to control. We're going to reprogram each servo so now they are set. Because you don't know. Then what's happening is when you're going to put the robot together, then one leg goes one way, the other legs goes the other way around, right? So you got to make sure all the legs goes the same way, right? So that's the idea for this. Okay. Oh. Get 13 of these things out. Take all these bags out. Actually, what I'm gonna do, so I don't get so many bags here, much clean to see. Gonna take all these out. Sometimes you have to use those, sometimes now, depends. Depends on the manufacturer how they decide you to use this little thing. Most likely you're gonna use one of those. Always you're gonna use one. One destroy one. Not the one that looks like an X. Or like, so it's not so many bags. So I can see much clearer there. So we take all these things out. Yeah, definitely it's a fun thing. Look at tomorrow, it's gonna rain. Looks like now it's gonna rain, but it looks really nice. Anyway, it's nice and fresh today. So let's put all these things here. We're gonna need that later on when we start putting together robots. All right. So let's see if we have to do the torch. How many there are here? I'm not sure. There are torchino more because we have the head too. Oh, make sure to lose those little tiny screws. Anyway, there's always some leftover. You see, I always tend to keep it. And the other rods, because you never know if you need some extra parts. Right? Comes handy. Okay. So let's see how many we have here. So we have 1, 2. Yeah, that's it. 13. There are 14 actually. So we're gonna only reprogram for it. So let's count again. Make sure. So seems I'm gonna mix this up. I got 14. So what I'm gonna do, I'm gonna keep this like this because I think they're all the same number anyway. I think all exactly the same number. So we're gonna keep this one with the blue thing on it. Oh, yeah, it has that thing. So we know this one is not programmed. Okay. So that's what we're gonna do. And I'll be okay. Guys, give me a second. I'll be right back. All right, let's keep that a little smaller there so we can see. And I'll be right back. All right, we're back. All right. Yep. Room 1. Wow.
Whoa.
A WAV thing.
Yeah, what a whoa.
On a WAV too. Yeah, that's because yeah, let me complete this. Oh, it's fine. All right, so let's look at the server. We're gonna put all at 90 degrees. It requires that always. Okay, so again, we're gonna connect this, and we're gonna look for the Hexapod debugging, and we're gonna upload the code. I'm gonna take this thing out. I don't need that. And let's go for that. Oh, you can see debugging, downloads, and if you already installed, okay, the module and the Pi, the board, you position pin 5, you will need to flip. Oh, okay, oh, I have to leave it. Oh, we need to leave it there. Okay. But why I need that for? I'm not going to connect. So let's set to 0. All right. If the program opens, okay. And then you need to try and upload to 0. ROM 1. When the switch is set to position stereo, you need to click that to upload the code into the board. When the upload to Servo then appears on lower left corner. Uploading. Pay attention. If you already installed the PLM module and your APAC driver board, you will need to proceed with step 5 and you need to flip. Oh yes, 0 to 1, which APAC driver will then turn 0 position, shows in the figure there. And the upload program successful must be run switch to 1 position. When the servo rotates, indicates successful debugger, you will need to replace and turn the servo and continue to replace to step back to debug in the next servo. Okay. Let's try that. Yep. Sure. Okay. I just killed the Arduino board. All right. Okay.
You had to get accept.
What?
You had to get accept on your phone. Welcome to MEDIABOXENT on Amazon Live. Ask your questions. We're here to help you.
All right. So let's open this up and I think we need to go into Arduino. Where's it supposed to go? Hold on. What? Debugging. Oh, Hexapod. I thought it said debugging or something. Oh, maybe it's there already. Didn't pay attention. Okay. All right. There. Okay. I don't know what I need that connected there. Put it in 0. All right, let's upload the code. Okay. It's already uploaded. So I'm thinking if I turn it on, it should move all at once. It stops there. Let's do anything. Okay. Let me see. I know this one was already moved. Let me see. Oh, okay. Yep. Yep. Okay. I want to show you this. So how do I know that the thing is working? So we upload. So within 0 means the program don't run. So I put in 1. Let's say now this thing is moved to other position. I don't know, whatever it is that, right? We see the servo right there. So what I'm going to do, I'm going to plug it for a second. And the program is running in the background. So set the servo at 90 degrees. So I'm going to plug this up. You see that? No matter where I put it, always it's going to get in the same position. Watch this. I should always get to the same. Right there. So this is set to 90. This in particular one. I don't know if that's required 90. But what I'm going to do, I'm going to plug it into all for a second. Let's say. Some move, some not, because it maybe already set at 90. That's why I don't want to check that. See, not moved. If not moving, it's because it's already set. They're already set to 90. I guess by default. See? I'm going to move this one out. Let me see if I can move it. Just the... They got gears, so that's why you cannot move it by hand. So I'm going to go and just move that a little bit. Try to move these things because of the gears. Yeah, see? So in reality, just plug one. Yeah, I'll set to 90. So maybe 90 degrees by default. No, this one move. Okay. I felt it. So you have to do this, yeah. Before you move. Before you build anything else. Let them move a tiny bit. And now the thing is going to work a lot crazy, right? So you got to make sure to... Oh, that one move. Okay. Okay. hope this one not damaged. Oh, I'm trying to get this one keeps moving. See something here. Oh. Okay, that's fine. Well, it's kind of moving. I feel like the gears keep moving. Oh, it's pretty cool. I like the way this thing works. It's interesting, right? And okay, so we reprogram all those things. And that's what I did. So let's go to the full page for a second. So it was pretty simple. If you review this part up to now, just connect and disconnect all the servos. By 13 and 1, I mark it with the blue tape, so I know that that one is not programmed or whatever. I actually programmed that one too, but they say that one is not programmed. And then you just run the program like always, the debug port, and it sets all at 90 degrees. It'll set to 90 degrees. If we look, I guess the program here, and I don't know why it has a connection for that. I guess really you don't need that. But they set it to 90. It should show me something. Let me see. So text, servo, forward, back, left, right, start. Oh, that was the other one. Up and then unlock that one, right? I guess this one maybe set automatic to 90 degrees. So show reset here. Oh, okay,
Hello,
I see.
Disappointed. Welcome back.
Oh, I see 90 degrees here. So I was looking what. So they use. I see what's going on here. So I was thinking, why they want me to use the Wi-Fi connection? Because they're using the same program for debugging, the one you did the test in the beginning. But I was looking, okay, where is Tommy? Because I see this. Here is a little line. It says that. Initial angle reset 90 degrees. So that guarantees to reset that. I do disappointed. So it sets out at 90 degrees on the code. Alright. And I think we finished the program up to here. So let's see what is next after that. 10. And okay, so after 10 we start putting together. So let me rewind a little bit and let's recap a little bit what we did up to now. Yeah, let's hold on a second and let's recap a little bit. I'm going to show you my windows here. All right. So how this thing is breaking down on on this particular robot. The robot we see now, I'm gonna go and show you guys. And this is what we building today, right? Or partial building is not going to be built today. Because normally it's going to take a little more time than what I expected. Because the way that is the instructions to follow and everything else. And the idea is to build an hexapod spire controlled by it's going to be controlled with Arduino. There is no other parts required for this. No batteries required. I mean, doesn't require to buy extra stuff. It comes with a lot of the projects. You will have to either get Raspberry Pi or get a memory, or go and get yourself batteries as well too. But this one comes with everything. Even though the instruction nobody included, it comes with the battery. So that was pretty good on it. And very important is STEM. So we look in science, technology, engineering
and math,
and art and math. Because A is for art and math. Okay, so and that's the base idea of what we bring you here every Saturday. I started after 1 o'clock in the afternoon Eastern time. The little different than other projects we had there put together. In reality, what we can have done is just jump into part 6, part 10, and the part 10 is actually how you start putting things together on the project. But the way idea, if you look at the instruction on this particular robot, was and get you into it, how things works, how the servo works, how the LED light works, how Wi-Fi, how we control the gyro. So the idea is based on, I don't know anything about robotics. I don't know anything about the Arduino. I never seen Arduino before. What is an Arduino? So they break it down in that. So it took us almost like what, 4 hours, 4.5 hours. 4 hours, right? That's about less than 4 hours just to go through all those steps. And the idea is I want to go straight because I'm just building like anybody else will build it. Even if I can jump to 10 and I don't need to know the rest of the stuff. But it's always good. It's always good even for me to refresh a little bit. So now you know why all those things are there. Because the idea is, sure I can build a robot, or sure I can build something up, but why is moving, okay, or why is doing that? So can they, you know what's happening, or why is causing those things to move, right? So now you know, somebody asks you, after you build it, you can, have a simple, here to give you a little more technical now, but you can at least explain to somebody, okay, why is that happening, right? Why it says to 0, right? On the servo. Very simple, right? With a 50 hertz signal, it sends every 1 millisecond, right? So if it's one millisecond every 50 hertz pulse, that's 0, right? And it was 2.5 in milliseconds every 50 hertz. Okay. It goes out to 2.5, it goes 180 degrees because it sends 50 hertz signal. Okay. So that's important for that. So it goes all those steps what we learn now. So finally now we are on step 10 where we put things together. So step 10. Let's put together tutorial assembly. Okay, component list, plastic acrylic. The acrylic plastic are fragile, so that please be careful when they're pretty thick anyway. But in some of the items can break too. Acrylic can break. Okay, the acrylic place cover a layer particular films. You need to remove it first. Some of the holes maybe in residue or some or clean before. Yes, some of the holes can be covered. They're pretty simple to remove that. Not much parts. Oh, the main part. Then you got all the legs to build. So we have the mechanical parts. Oh, the screws and that. I remember it comes with the screwdriver and all that. How many screws we have those? The parts that we already reviewed in the beginning. The type of things, the batteries. I'll tell you how to do the battery thing. I'm gonna use that, but be free to put it in. And we need to build that first. It's always that part. To assemble the follow components, we need to follow this thing and assemble the final components. So I know for today, I'm going to be using the connection for the control the board. You can use any USB cable if you want, long or short. Got a bunch of bags here. I'm going to chuck them out. All right, now the batteries can go here. So in reality, what I need to do is get one of these things out. A little different. I think normally I'm going to keep it the other way around. So that's here. I know I'm going to need some screws, screwdrivers. I'm not sure the size I need right now. I know that I don't need any more. I don't need the batteries right now. They're charged. And I don't think I'm going to use this right now. But this, yes. So now, I'm not technically, I do not like to take everything apart. It's a big mistake if you do that. Gets a little crazy. Alright, so what I was doing, sorry I didn't show you that. And I'm going to keep this so you guys can pick what we build on the side. So that's what I did. Keep everything there. Take the boards out. Keep all the screws out and then see what we need. So I need to find that square thing. So I know it's not here. So I'm going to keep in the box right there. And they're here. This. So how many I need to build this? It shows me one component. Oh, okay. So we're going to be building that too. All right. So let's put that together first. So let's just follow this. So we need this. This is extra stuff. This guy with laser.
I keep it until the end because remember what happened the other day?
Oh, no, but that one is...
okay.
That one is just the part of the... When they come with the laser. Yeah? Okay. And we got to get one of those program already servos. And if we look, this, we got to make sure this, because I did that already. Okay, so we need to do this way. Nope. So where they have this, like this. Very important because then you got the legs the other way around. So it looks like it's this way. Right? Now we're using none of those things right now. I think so. So we need to get M2. M2 nuts. And 2.8.
Take messages, Papi.
Yeah. Okay.
You're good.
All right. So, and then we're going to go into M28. So this one. So this one's
really
here.
Multitask. We do so many things.
Huh?
We really do multitask. We do so many things. We organize the warehouse. We clean the kitchen. We live
Oh,
stream.
you did that. Okay. All right. So we have it there. So what do you want to do today? Gonna go Portuguese restaurant? Okay, so let's go this way. Oh. M2. So we're gonna put this here. Right there. And we pull the first guy. That's sort of got a lot of power, this thing. Okay. So we're looking around the bottom. And let's look that one out. It looks exactly the same. That's what I'm looking at. All right, so we got that. In case you guys coming in now, what we're building is the little picture in the what you guys see in the side. We're streaming already from 1 o'clock in the afternoon, so it's a lot of parts to put together. Not a lot of parts, a lot of learning to this. Okay, so we have that little guy there first. You guys can follow along that, and then we need to follow those parts. So we need to get M3 nuts. So let's put this there. So I need N310 now. N310 nuts, much bigger nuts. Lock. Okay, M310 nuts. And number 10. $16. Number 10. What are your number 10 screws? Number 10. All right. And I need to follow. You want to take this? What happened?
No. I was entregando para makeup.
Oh, no. Okay. So I need to follow those guys. So let's get those things. So we need to see one that looks like a U thing. All right. So that one. And I need to get that little leg thing here. So, okay. Let's find it. It's this guy, right? With 3 holes there. Yes, that guy there. Alright, so we got this. So first thing we need to remove this tape out. For those coming along now, remember we every Saturday afternoon after 1 o'clock Eastern time, we pull a lot of stamp. We want to call the toy. We can call the toy for the stamp. Science, technology, engineering, art, and math. And that's what we're building here. We build robots from the scratch every Saturday after 1 o'clock. And we did put a lot of robots together, coming up with more STEM toys. Now, sometimes toys, the word toys is like, oh, it's a toy, but this is like beyond a toy. Thing is learning. Very important to introduce children's STEM. So learns us to deal with frustration. So when we are an adult, we can handle things much better. Yes, this is for No matter how young or how you are, it's always time to learn something new. And I think the most important here is fun. It's an enjoyment after you put something together. That's what it counts. All right. So I need to get 3 of those things here. Pretty clear instructions up to now. All right. So we got 3 of those. So we're going to need 3 screws. So, all right. So the idea is, well, I can't put that because if you put that now, it falls. And it kind of tricky sometimes, see, to put that. Do not force this thing. You think, okay, you have to find a way to put it in. You have to rotate it until they actually got in. Do not try because I already did and you can damage this thing. Okay. Oh. See, but we're not. No. No, I don't want a brown container. All right. So then I put that together. Let me see how this thing we're looking at. So we're looking at this thing like this. Oh, like this. Okay. All right. That's what we see. That's what we see. Yeah, they show you to put it, but you can't put the nut there because if you not, it fall off. Okay, now they assemble it first this way. Yeah. All right. Yeah. I know they show you put the nuts there, but you can. So what we see here? Yeah, we're missing a view of something here, but okay, let's figure out this out. All right. So we look this way. So this will grab the motor. All right. All right. Yes. There. Okay. Yep. So that's the way it needs to go. So now we're gonna put a screw. We do that. So the tricky part of this is this nuts, and then you need to hold it with your other finger and try to send it to the groove there. It's a little tough, the first one, because the whole thing is sharp. So I'm holding with my finger, everything. So let me see. Maybe, let me see if we can put, if we do that. Yeah, maybe this way. But you need to still, okay, there. See, it will fall off. Yeah, just went in now. Yeah, we need to keep it that weight. Because you can. Let's see if we can go a little bit there. So we want to. Okay, there. Okay. All right, now. So you got to make sure this clicks end. Follow the groove. All right, there. Yeah, be careful. Do not try to force that. Okay, that's perfect. And another one there. I'm not sure to put it at first. You can. You're not gonna be able to do that. So you have to go like this. Do not force it because I didn't know the projects. You think, oh, the nut doesn't fit, but you have to rotate the nut because and to has the flat position to, goes in. But it make a little, okay, there, make a little hard because the whole thing is black color, so it's reflected light in such way that is you need like more light, right? It's absorb the light. So see, it comes with the screw. So now we did it, and let's put this one. Oh, this one's gonna be tough. Oh, all right. Maybe I can just hold it slow, because I cannot put my finger to the other side. All right, go slow, my friend. Oh, all right. Oh. So how I can treat this one now? Maybe if I put the screwdriver from the other side, and we go something this way. Yes, I think that. No. And it's hard for seeing the camera, I think, too, because of the color. But in this case, what I'm just doing right now. Oh, nope. Nope. Oh, went to the floor. No worry. Should be always some extra stuff. There always some extra. Okay. Yeah. Hey, what's going on, man? Everything good there? All right. Go Saturday today. Here the weather is like, it's like temperature is still, I don't know if it's cold, it's hot, but it's perfect. Just the other windows open. That's why I like this type of temperature. Man, you don't waste the energy at all. You don't need to have the AC on. Oh man, this is a tough one. You don't need to have everything is like good. It's perfect, yes. It's a tough one. Okay, let's keep the screwdriver there, flat. Because in reality, only one way. Not one way, but okay, there. Let me see. Okay, there. And you have to use because you cannot fit you. Oh my god. Man, if I gotta do torsion like this, I'm gonna go nuts. To figure out some other way in the next one. Yeah, I wonder, can I put that together before the motor? I think so. Okay, let's look at the next one. Gonna look on my next bill. Gonna look at the next bill, see if we can figure that one out. Come on, my friend. Go. Wow. All right, hold on a second. Can I?
Thank you for following, Rosa. Our follower of the day.
All right, I think I can. Okay, hold up, because maybe. All right, let me take this apart 1 second. I wanna do something here. I think I can. Yes, because can be done that before that. All right, so let's see. Oh no, I can't. Oh man, because that's part of this thing. Well, no, you can't. Yep, and this thing is not going to hold here. I think we're gonna do this. We're gonna put a little blue tape there, and that stays there. They had to take the whole thing apart. Now screw it up. Okay. Now I got to review again. Okay. Yep. I think maybe it's a secret. Put a little piece of blue tape or something there. Scotch tape or something to be able to do this. Then you can just remove the tape out of there. Or leave it there. I don't know. Okay. Alright, that did it. This is different because I can kind of hold the nut from the other side. From here. Remove this one first. This is the only part that is tricky in all these projects. And it goes just exactly so this thing doesn't rotate. You know what I mean? Just exactly there. Let me do that. If not, the nuts will go through. That's the problem. Come on, baby. Come to Papa there. Come on. Go there. Okay, there. Yeah, you can't force these things. Don't do that. Because I did that and you're going to crack the acrylic. Needs to fit right there. Okay, that's it. And now you will crack this thing out. Okay. See, this is the way we're supposed to do it. Yes. Yep. You don't need to go that crazy. I think we need to put one more. You didn't have to remove it from the beginning. In this case, I got all the black screw. The other ones was just all like a regular screws. All the projects. Nice touch for this one. All right. Oh man. That was tough one. Not tough, but alright. So let's review this up. Make sure we see what we're supposed to see. Right? Because if we build this wrong, pay attention to the direction. Yeah, reverse. So let's from the same weight. And I think we find. Right? I think we're good on it. Okay, so we get the first one is done there. It's a nut right there in the center. Yes. Okay, yeah, because if we build this wrong, then because I had that experience with all the robots I built. So we're looking like this. All right, so we got this one done. All right. Now we need to assemble that one now. I'm not sure what. Okay, let's see. Okay, so let's follow another servo here. Get another guy. And after that, well, I'm gonna grab the the little loop thing. So we need some M2s. N2, 8, and M2 nuts. All right, and we need 2 of those. And 2 nuts. 1, 2. Let's get the thing there. I think that's a part of the leg. So let's find that out where they are. Here. It's a left or right. So I think that's the one we need to get. We need to remove the little paper there. And right there. So let's see. Okay, so back view. All right. From view. Yep. Okay, this way. If we look in this way. That's it, perfect. There is a little legs. For the little spire here we're gonna build today. Well, part today. We're not gonna be able to build the whole thing today, but we're gonna complete this next weekend. Next Saturday. Remember guys, we are here every Saturday after 1 o'clock where we put robots together. STEM, science, technology, engineer, art, and math. So if you're looking at a channel that will do that for you, this is here, MEDIABOXENT. Then we are here Monday to Friday after 5:30 in the afternoon with more tech, home, and more. And then in the morning, meet Menina. Decoration, home items, yes. Yeah, no, she's working in the warehouse now. All right. Alright, so we need to find the little screw. Okay. Self-tapping screw. Okay. One self-tapping screw. But this one comes with that. We need one M2. M2A. Okay, no nuts yet. Man, it smells like food. I'm hungry now. Okay. And we need the rock arm. Rock arm. What is the rock arm? 1. Oh, okay, I'm sorry. When you run the rock out. Okay. So we held the parts. Exactly what it shows right over there. And okay. And then we're going to put this together. Yes, I'm going to go do it right now. No. Do not remove the direction of the servo after assembly. This already been assembled in the following same steps will remain with the 2 left side. Two components are together in the rack arm, and the components are rack arms and being installed above. Okay. Oh, and I guess repeats again. Yeah, but you didn't show me how, where it goes that one out. Because this one, so this is the leg. This will be the hip. Oh, okay. All right. See, they didn't show you that there. They should show you that part. I say, what, okay, so you think where this thing is going to go? You're guessing, right? Well, it's supposed to go here. That's supposed to go there. They're mixing that view. So they're mixing that view. The question is, if this goes, if this is this way, that needs to go inside here. Yeah, they're missing that view. I know because I already built this thing, so. Okay. So that goes like this. And this one goes this way. Okay, but hold on. It should be the. Can do that. So build this one run. So we put this here. The motor goes. Oh, like this. Okay. And like this. Okay. I threw the screws out. All right. So we gotta make sure we center this and center, and we put it somewhere in the middle. The screw. Okay, you gotta center it right there. And then we use a self-tapping screw. You just use one only. Just to hold this. I know, it's crazy. It only takes one, right? All right. So we got this way. So in reality, we see this. We see it. We view this. You have to view the back way to understand this better. Yeah, you see? So this is just the legs. Alright. So we put this here now. So we put a tray there. And that should be the one, I guess this is the one that connects there. Let's see. It's an M2 there. I don't think so. M2 will sit there. Hold on a second. Hold on a second here. No. That's a 9M2 there. No, no way in M2 there. and M3. No way you can hold up with it. Okay, so let's see what happened there. Normally say all the time I'm the one who make the mistake, not the company, but or we can use the one that comes with this. See, it's an M3. Or we can use the one that comes with a little bag. It doesn't tell you there. Because you gotta hold that thing out. Okay, but this is too short. Yep. Or maybe in 2.5. They read that right. Oh, okay. My fault. 2.5. Not an M2. Okay. See? So where's my fault? Alright. Yeah, I knew it cannot be that. So we're gonna press this down. And yes, voila. That's it. So that's what we see in here. This is the leg of the spider. So right, this is the hip, right? So the way this thing opens, right? So this thing goes like this, right? So this connects to the main body, and that's the way it works. Yes. Oh, okay. Christian, thank you to follow MEDIABOXENT. And what I know that, can you pass me the big one, the biggest fire? Pass me the big mama. Oh, you want to see? I'll show you guys something. All right. So again, and this one will either go open or close. Why? Huh? You should spire outside? No. Oh, okay. So what I know that, because this is the big mama. So this mama is going to go babies. It's going to create this little baby here. And this is what we're going to do. I'm going to do. I say, okay, you see, this one has baby, and that's a baby. That's a baby one. This guy has some power. When this thing comes on, this servo has some power. They can actually break something. It really goes up. You can feel when they push the leg on this guy. So this is the big guy. So that's what I know, because see the idea of that. You see that kind of reflects what I'm showing you here. But this is a baby one. This is a big mama. This one is a big guy. It weighs 8 pounds, guys. This is a pure robot from the Terminator. Not from the Terminator. From for the Stargate Atlantis. I feel like watching again the series. It means so old. Stargate Atlantis. Watch that one. They're called the Replicators. All right. So that's the guys. All right. So this is a big guy. I'm gonna put it on the floor now. That's a big guy. And then he's gonna have babies. And these are the babies. All right, so finally we create the first leg of the baby. The baby spire. So I guess we gotta create 6 of these. All right. Okay, so let's go and let's see. Yes, it does reflect to that. So I guess we need to create more of that. Yes, so let's create more of that. Now we're gonna double lap this thing. Okay, before ensemble it, okay. So we got one of those. Let's find the next servo. We need to get a little square thing there. There's somewhere here. Alright. So we need this guy. So what are we doing today? Oh yeah. Oh, I want to see. I want to open. I feel like opening. No, now. Oh, do an open box? An open box show? Alright. We can do an open box show later on then. Oh, we think it's open. Okay. Alright, let's see. Let's see what we got. What we got here. Okay.
Yes, I want to see too.
Oh, you want to see? Okay, so we got this fresh from
Guy from Amazon.
let's see what the guy from Amazon dropped to me today. Let's see. Let's go and see. Let's pick. Put a pause a little bit to the previous show and let's see what we have here today. Amazon dropped a bunch of boxes, so what we got here? Okay, what we got here?
Oh, my conditioner.
A conditioner. Wow.
Boring.
Boo. A conditioner. What is this? Shampoo. Boo. Okay,
I didn't know.
take it. Give me some more. So give me some more actions here.
I didn't know.
Let's see what Amazon has dropped to me today. All right, so let's go. Hold on. Let's see if we get a little more action. All right, let's see. Oh, hold on, one at a time. One at a time here. One at a time. No surprises, right?
I know.
Okay. Unless they send you something we don't know. Okay, so what we got here? Boo! Related kitchen. What is that? What is this? What is this? Woo! Okay.
That's fun. That's fun.
Oh, that's fine. Can I put the robot through here? What we have here? What is this? Rotated drum gear.
Here.
Gear.
Oh.
Gear or grader or whatever. Okay, so you put the meat there and okay, I see.
Later.
Grader. Okay, so okay, yes, I see. Okay, that's cool. Put that and get a bunch of potato, carrot, and go for the salad. All right, I'll take that.
That's fun.
That's fun. Okay, I take it. Fun project. Fun.
Fun is like here.
Oh, I'm sorry, man. I thought you catch it.
Yeah, but
All right, so let's go. I hope it's enough fun. Okay, batteries. That's cool. When it has a signal, it means there's something cool on it. At least for me. All right. What is this? Sometimes we gotta definitely. Okay, take this box out. Okay, electric air duster.
that's fun.
Okay, powerful air duster. Up to 35 minutes of battery life. Compressor condenser, low noise. What we have here? Oh, so this is for the computer. So this is for the computer. So this I can go and clean. Okay, I said this is cool. We'll bring it to the next live. We're gonna do an open box. Okay, next time. So don't say anything. We just reopen stuff now.
I think I was got here.
Well, you know what? You need to charge it. So that's good because you open this next time. Oh, let me show you this thing, and then
Oh, what a surprise! It was charged.
and not working anymore. You know. So charge it. Okay. Just put it to charge. It's no charge at all. So it's dead. Okay. It's cool. Okay. So we clean the cut hair and stuff out. I take it. Put a pause to the robot. All right. Let's see what Amazon has dropped on me today. Just put it in the side. I don't know if I can charge it. Give me see. I can charge it here. I think. Let me see. Give it to me. Give me the little thing. No, not the box. Just this stuff inside. Oh, I think I. All right. It comes with a cable there. Oh, is there a cable inside there? No. I got it. Oh no, USB Type C.
Yeah,
It's USB Type C. Oh, that's cool. USB Type C. Okay, let me charge it right now. I don't know. Okay. It's a mini blower. Oh, talking about robots. My next robot is here. Oh, you didn't know? The robot was coming? Alright. 4-wheel car kit. Another word robot. Yes, that's what's in the pipeline. So you had there's more robot coming in. So yes. So robot. Cool. That's a happy face. Yeah, I think the little one should be somewhere there then. Alright, so let's see next one. This is what just dropped. In the front of my house today. Okay. What is this? Makeup brusher set, Menina, for your show. Yes, I don't know. Okay. Let's see now. Let's change things here. Changing gears a little bit. Ooh!
I love that.
Ah, Menina loves that for her show. Catch up for show coming up soon. Oh, makeup thing. Ooh. Okay, boo. No boo. Huh? Oh, okay. Alright. So. Okay, yeah. Wow. Alright. Yeah, what is that? Yes. Next time we're gonna do that. We're gonna do open box. And meanwhile we're doing some other stuff. Okay. Take it. Alright. That's it for now. Oh, that was just too big. You can. Okay. Alright. Oh, that's the other thing? Oh, just leave in the box. Put in the car. Yeah, just leave in the box. Okay, and then to your huge boxes that are impossible for me to bring it here. Alright, that's cool. Alright, have fun with your makeup projects. Let's continue with this. Let's resume the project.
All those cables.
What happened with the little robot? There's supposed to be a little robot, like a cat robot. I want to stream this. How you doing? You want to stream what? The open box? Let me put it. It's too much mess on the table. All right. Let me get a little bit more what we're doing right now. All right. Yes. Yes, we do rather robots here. The robot show. No, not the robot show, but all right. So let's put that together. Ryan, yes. There's a check mark there. What's going on? What is new? Alright, so let's put this. Okay, let's find the shoe. It's screw for the robot. 2.8. You like the brushes there? That's for cruising brochures? Ah, for any time, I guess. Oh, you're gonna test it? Oh yeah, test the brochures. You have to. That's why they do it. That's why we are here. All right, we test the brochures and everything. So what's going on, Ryan? What is new, man? No. Concentrate, Dario. Concentrate, because it's not enough. Once I gotta put it in. Concentrate. Okay, so see, that one has a little thing there, and any point of the tummy to do that. Okay. Well, in reality, it's supposed to be 3 legs, 3 left legs, and 3 right legs. That's the way it works. I wonder if we're building the okay. All right, come on, baby. Okay. Okay, we got that going on. Now remember, we stream about robots every Saturday after 1 o'clock in the afternoon. We build the robots. Right now, be building the baby because we already have Mama here. You want to see Mama? Mama, come over. Believe me, when this guy comes along, you'll be real scared. All right. That's a big mama. 9 pounds, 8 pounds of pure robotics. Believe me, when this thing is on, you can really see the power of these turbos. This guy is heavy like crazy. He has camera detection and everything else. This guy is a big guy. So what we all now, we're building the little baby one. You know, first we need Mama to build a little baby. Then we're going to be a big fight, Mama versus the kid. Or whatever. Something that way. Or robot versus all the robots. Alright, so we get that. If we're looking... Okay, hold on. Don't look at that way. Alright, so what I did wrong. Okay, you tell me to do this. And it's supposed to look... Okay, so it's wrong. It's supposed to look this way. And no. Man, the build wrong. Yeah, I don't know. It doesn't show me to put that thing together there. I don't know why. Maybe they just put it together for the picture. Okay. I'm gonna, yeah, because if you do this the other way around, believe me, I had the experience that when I built Big Mama, oh man, I went crazy. Oh, hold on, the legs on the left, the leg on the right, everything was nuts. So we're gonna go this way. Let's do this thing right, and then we're gonna go this way. So this is where we need to see this. I think this is, it has to be the left or the right side, one of those sides. It gotta be. Now, why didn't it make me build all the right side first and then all the? I'm not sure. I'm just following exactly what I'm supposed to do. I don't want to go ahead of the game because that's what the show's about. Anyway, we just follow the instruction exactly. If it went the same way, you will build it. And I think it's real nice to do this type of things. Again, this is for everyone, no matter how old or how young. Remember STEM, science, technology, engineering, art, and math. All right, perfect. We got that. What is my next step? Bring these things a little bit here. All right. Okay. So I'm gonna assemble a companion. All right. Didn't tell me that. Okay. Companion boats. Okay, so we have this one like this. No. Okay, so this one is like this. And I need to assemble the other one the other way around. So the other one we something like this. Okay. I'm not sure why I gotta build this way. It will make sense eventually. Because I already built one leg. And I don't know why we should build all this way. But I don't know. Let's see. Gotta be a reason for it. No question. I do not question the instructions. Because every time I question is when I do something wrong. So if that's the case, we could have another one. Remember, there needs to be reprogrammed these little servos. So we did that a while ago. About an hour ago. So this one, it looks that way. So this one's going to look this way. Exactly that. So we're going to find again a 2 and a 2 there. All right. M2s here. 2s, M2s. Okay. And 2 and 2s here. We put that together. And another one there. All right. And we got the companion. All right. And what we do with the companion. Okay. So we do that. Like we did before. All right, so we need to find to this one of these guys. Hey, one of these guys. Okay, we can build in 2 of these things. Exactly the same boats. Okay. So let's remove this up. Okay. All right. Patience, patience, patience. I learned to have a lot of patience with this. That's the nice thing about this. Oh. Okay. Get that out. Okay. Okay, we got one out. One more. Oh, nice. Okay. Oh, it has a light on it? What, light up inside or doesn't? Huh? Oh, I don't know. No, I don't know. Where it light up?
Like the other one. Smart.
That one is a smart mirror too? You with the time and day and all that? Oh, yeah, I see. Oh, no, only light or is it smart? You can say mirror, mirror. Who is, what is the line? What was that famous line? No, the mirror. Oh, put the period? Yeah. Period says yes. Yeah.
Of them all.
Of them all, yeah. All right.
Wow.
Who's the number one robotics? Yeah, that's the mirror. Who's the number one robotics? Okay. All right. All right, so let's put these guys together the way it shows the picture. Yep. All right. Are there two of those? I already got it. There, those two. Oh, okay. I said, wow, I'm crazy. Okay. And like this. And now we assemble that together. And like this. Oh, I can't hear that. I can't hear that. Okay. And exactly that. All right. So for this, we need some entries. I need 6 of this. All right. 4, 5, 6. All right, 6 of this. Not sure what is the best one. Okay, sorry. Be careful with this part again because if you force the nut, you can break it. You have to rotate the nut until it goes in because it catch the corners. If not gonna, you think, oh, the nut is too big, and you try to force it, you will crack the acrylic. Okay, so be careful with that. So, in reality, if we reverse a little bit there, that's what we're looking. And I think both needs to look the same way. I don't see. Oh, okay, so we'll get to that one. I'm gonna do that one less because that one is hard. Huh? And let's put this one there. The only part that it requires a little bit of patience. Oh. Okay, there. Okay. So that we hold the assembly there. Alright. We just have another screw here, but this one is hard. So what I'm gonna do, I'm gonna put a little piece of tape there. Because if not, the knot will go through there, and it's crazy. You go crazy trying to figure out how I'm gonna hold that. I guess you cannot fit you. Oop, I don't want to lose another one. Okay, perfect. That's the little trick there. Put a little piece of tape the other side, and then you remove it. If not, you're gonna go nuts. Okay. Now we'll remove that out. And we got the first one there. If we look like this, it's exactly that, right? And let's move to the next one. Let's do the same thing. So no, it's going to be the same because that's a companion. So it cannot be the same. Cannot be the same. That kind of, yeah, cannot be the same. Yeah. So let's look that, because that's the other side. So we need to make one that's going to look the other way around. Like this one. So let's see, because it has to be one left and one right. So what we did here? And I hope these instructions are clear. I hope this is clear. That's fishy here. Yes. All right, I think this has to be your right side. Something's fishy here. Something's not coming out right. Let's go a little farther there. Right. is the left and the right. Physical map on the left. Alright, see, don't tell me to build the legs if I know I build the legs here. So we need to build 3 one side and 3 the other side. I think that's what it is. It has to be that way. Because if you look the robot, right, we have left and right. So in reality, this is the left, and this one has to be the right. So this one cannot go that way. Okay. Sure, not clear there. What do you think? Yeah. So this one is just a companion of this. You know what? I gotta build 3 of these guys. I know that. And then 3 of the left ones. Total 6. So this is gonna grab. And we can see, I'm right. Now we can see it better there. So that's gonna grab this side. Maybe the other way around. So let's see. Build the same now. So looking at the model this side and this one. Oh, they're the right. All right. So this is the right side then. All right. So let's build 3 like this. Let's not go. Let's build 3 that way. So we got 1 here. So I have to build the same exactly thing. Yeah, so this one is my... I gotta go beyond that point. So this one connects here. Yeah. I lost track of this. The instructions not super clear, but alright. Alright, let's build. Okay. Cat! How you doing? Minia's here in the background. We're building another big mama. No, this one is a little baby of the big spider one. So this is the baby one. Alright, so let me find out these little legs here. Here, let me get these things out. I know I need 3 of these. So let's grab 2 more of this. Okay. Got 2 more of this for now. Okay, and Perfect. Alright, so another one. I think this is the most time consuming, this part. The build the legs. The rest of the stuff, it goes much faster. Okay. All right. So I gotta build 3 guys like this. I don't know why they don't show you build 3 guys just the same and gets repeat itself. All right, so let's go back. Fine. If this and this side, come on, let me check this one out. This is the one I need. All right. That's exactly what I need. If we're looking at this way. Nope. So this one is yep, yeah. Oh no, I didn't know. No, you know what? You're right. I need to look for that. I need to look for the frog. I need to do that. You're right on that, cat. Okay, this will do it. Let's go back for a second. Let me see this one because I want to build 3 trees like this. Okay, we got there. So this one is like this. And then we needed to put together. So if we look in this, it's this way. So this one goes, so confused right now. What are you doing? Like this. Right, but we view end. Yeah, that's fine. Exactly like this. Okay. So let's do my cheesy screw first. That one. So the only part is just try to get a nut into that groove there. So the screw then can go the other side. Okay. I need to tack that one there. Okay. So the baby stay there. So one. Okay. Yes. All right. So in reality, it should look the same like this. Yes. So that one there. We gotta get another one here. I know the spire. You see that the graphics there on the right in the corner in the bottom, right next to the start of the bubble thing there. Yeah, bottom right. That's what we're making. Next to the flyer, next to the banners. A little smaller than the other one. I think it's a look big in the end. But all right, perfect. Put another piece of tape there so I can figure out how to put that now there in an easy way, because if not, cannot do it. So let's put the nut there again, and that fit now. So you have to rotate this. Okay, perfect. I think that's the tricky for that. All right. So the tape went off. All right. So this only part that requires some little patience on it. Then I think the legs is the one that's just more pain, because you got to put this motor, and it's hard to. Oh man! All right. So up to now, it should have exactly the same. So we need to grab one of these things. Maybe we're gonna grab because I think that's exactly what I did. So we're gonna hold this here and we're gonna put down. Doesn't tell you in the instructions this. It seems already built some of this. I know. They show you there, but they show you where you're supposed to put it in. And you got to put it right in the center. There. And that's perfect, because this is what we're looking at. Right. So the robot can move this left or right. So to walk, it goes like this, and then opens or closes this part, right? And the way it walks is like this. Each leg, right? So then we have to grab another motor here. Oh, okay, use this, whatever. Okay, so, and this will be exactly the same way. So like this. So this one, it will connect like this. Let's see. That is right. Yep. So that we have to build another one like this, right? Total 6. So this thing is the same. For that we need to grab so an M2 there. So this is because you have the right side and the left side, right? So that's your right. This one is your right. I thought it was the left, but it's the right. And I'll show you what I mean. If I move a little bit, you see that there? So we look, and this is this side. Then we got to build the other side. So I'm going to build these guys for now. Gonna build another one of this. So we have this thing. What would be nice in the instructions of the other one, just build this first. You're right. So you have all this. Then okay. So in reality, this one connects, but I'm not gonna put it in yet. Connects like this. Right, but in the meanwhile, I'm going to build another one like this. So that way it's much easy if you do that. Right, so that way you can see one, you build exactly the same way. Alright. So I think the show is supposed to be that way. I think it's much easier that way. Tell you, okay, bring 3 left and bring 3 right. At least you don't have to jump. And all the time, put this together. All right, come on, screw, nut, go there. There. And here. Okay. And now we got these two. Perfect. All right. So in reality, I can put this together now. So this is the top body. This is the leg. So actually, hold on. See how I did this one. Oh, this one I built it wrong. All right, that one I built it wrong. One goes like this. And an M2 2.5. Yes. 2.5. No. Yeah, try to put it straight, doesn't tell you there, but you don't want to move the servos either because they are already preset. Remember, 90 degrees. All right. Okay. And this one I did build run. The other way around. So that way I have my three right legs. I think that's better do it this way. Okay. So like this. All right. So that one there. 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 Oh. Perfect. So now we need to build, another motor, exactly like that. Like the one we built in the beginning, because we like that, because we're building the right side. Okay, so we need to get another motor. So total 13 here. So 14 actually. Say 14, yeah. So let's look for another square thing there. So I know I need one of this for this part, all right? I know I'm gonna need one of those. And I know I'm gonna need one like this. So no. Yeah. Got that one there and this one. Is that one the side for now? All right. Okay, we get this, right this. Yep. And I need to get one more. Okay. Okay, one like this, and I need to get the leg. No, the leg I have it there. Okay, yeah, I have it. All right, think. Okay, what else I need? Oh, I think that's it. Think. All right, so let's build this guy first. So we're looking like this. Exactly like this, because it's going to be just just like that. Perfect. So we need some little nuts here. Again, 2 and 2. And one here. All right. So we got this guy. Then we need, yes, one of this. Oh, and the little square thing here. One of those things. Oh, here. All right. You need to take it slow sometimes at chest area. If you take it, let's take it slow. It comes all in one and one piece. All right.
Yeah, the other robot is arriving on Tuesday.
Oh, the little one. All right. So we need some N3 nuts now. M310. We need 3 of this. And okay. So that's what we need. Exactly that weight. So again, if we put this together, we're going to look this other way around to make it much easy to assemble it. See. So this goes this weight. See there. So if I look in at the one already built, no, what to do it. Let's go back. I'm trying to cut corners here. Okay. We go like this. Here we go like this. They don't have like a super view. Well, this time they did it with pictures. The other one around, it was
the other one was like cartoonish, so
cartoonish. Right. Yeah.
Stacy, yes, so long. Hello guys, do we get a discount if we order? No, what you do is actually you help MEDIABOXENT by buying from the carousel. But for now, we don't have a discount. We can try to get a discount for next time, maybe. And these are extra robots. I love this so much.
Yeah, you're still paying the same price if you get it. Just helping us a little bit. Sometimes we get coupons, so but not today. All right.
Excellent question.
Excellent
question. Yeah, I would ask first before I buy to see if I get a coupon code or something.
Oh yeah. That's true. Why not? Yeah, well, we say, yeah, we got a super coupon code. You know? And there, click. Went fine. Yep. And this part is just pain.
Because the fingers are too big.
Maybe. No,
but
no, and also you have the nuts, you have to put it in. You have to put it in a such way. And now you break the acrylic. And also because of the color, it absorbs the light, do not reflect the light. So kind of it looks like I need more light than normal. Oh man. All right. Let's concentrate. I'm losing my concentration right now. All right, I need one. Need one to lock, and then I can do this. Much harder is the first one. Then, all right. Oh man. Okay. Okay, yes. Okay. Ooh. That was tough. Because it's exactly done. They're not even put a millimeter extra. But I think because if not, it will rotate. I think they're not. That's why they did it that way. But I think if it will be better if it did a little bit bigger, tiny bit bigger. I think I've run out of power. Oh, it's off yours?
No, it's fine. We're live.
No. I thought it was off.
It was. I realized just now. That was mega testing.
No, I think it means as long as you keep it, yeah. Has nothing to do with oh man, I can. Hold on. I'll be back. I gotta go. We click there. Yes, there. All right, we back. All right, right there. Okay. You know, it's funny because of the color and its acrylic reflect or absorb the light, and it's much dark. It's hard to see sometimes. It all the same thing. They all have the same problem with these nuts, but not just this. All these projects, because it needs to fit exactly to the. I wish they would just not do it that perfect. It's not even a millimeter left. I can't do this. Not even 1 minute. I mean. A millimeter left, and let's so the nut can fit. It can fit anywhere. You know what I mean? I think they do that so that the nut doesn't rotate, but it's a nightmare. Oh, you want to test that thing? Yeah, maybe I need that for a little bit, so I can go. You have to put it with that. If not, it's not gonna fit. Finally, I got it. Oh, okay. Hey, what's going on, man? Hello, guys. Did you get a discount in order? Oh, okay. You read that. Oh, let me see. There's another message. Okay. If we get discount. Not really. Not really. If you buy 100, if you want. Sometimes we can get codes, but not all the time. We don't have code for these products. But we find out what you like to build. Like this one, there is one particular one that you like to build. The one we show, because we did build a bunch of different robots. You have to let me know. Maybe we can try. We try to get codes. We see if we can get maybe for the next. That you have to actually give it to me so I can relax a little bit. Oh. Let me see.
You can do it.
Can do it with this.
Style.
I know. People says, "What are you doing?" Let's get it a little bit.
I love it.
You know, the sound never stops. Actually, as much as rotating.
I know.
The frac. The big harbor. Oh, okay. The big one I built. Like okay. We see we can get we see we can work it out. Yeah. Like this guy, right? You want to build this one? This is so cool. Yeah. The biggest support robot. Okay.
That's fun.
We see if we can get. Okay. Let's do the hammer a little bit. Watch this. And with from our side, right? You know, it will never stop the sound. I think
like church.
So this make you like relax. You relax with this. And it will now, it resonates. This is quark, so it will as long as I keep rotating, it will resonate all the time. So they use this for just relax, meditation, relax, and it's pretty interesting, you know. So let's go again. Let's relax a little bit.
Oh yes. Oh, CS wants to see a big one. Yeah, we're gonna show it like in a second.
Yeah, I should. Yeah, they should. I should again.
Okay.
man.
That's the OHM, something like that. That's loud.
That's loud, right?
Do we have the machine to test how loud something is?
It's loud.
It's loud, believe me. I think the whole neighborhood is relaxing now. Wow.
Man.
It sounds beautiful with the birds on the background, the birdies.
Okay. Do you want to grab it?
Okay, you're relaxed?
I'm relaxed now.
Okay, I'm gonna go get it.
Unbelievable, right? Be careful. Yes, be careful with that. So these are the big guy. These are the big guy we put together the other day. No, you have to keep it. You have to put it with the ring. Okay. But this one looks pretty cool too. So let's see. So we got this finally. Just do it and then start rotating, although it'll not stop. Oh, hit it out. Be careful. Hit it and then go from our side. Oh, you see? You thought it was easy. All right, so we got his little guy, finally. All right. So we get this, but before that, we need to get another one of these little things here. And this is going to go.
CES wants to compare the size of the big one with that one. With the big one that we showed you already, we're done with it, it's definitely bigger.
Oh, yeah, much. Well, the Servo says 3 times bigger than everything.
Yeah.
Yeah, it takes 2 batteries. Oh, yeah, much powerful.
It's
too.
fun. Fun.
But I think this one looks pretty cool, too. It's a little different, this one, too.
We can play with those tonight. I'm serious.
What?
We can play with those tonight. You can put some cat treats on top so the cats follow it.
Okay. So we're going to put that right in the center. Oh, no. That's wrong. That's wrong. I'm actually put this in the center. Yeah, put it too far. That was the problem. Okay. Should we here? Yeah, that one there. Takes one screw only.
It sounds like church a little bit.
Well, yeah, but yeah.
Because I was like on the other side. I was on the other side. And I hear it and it sounded exactly like it. For me. From far away.
So now this is the top. And this needs to connect it here. So we're gonna put it straight, right? Perfect. Now we need to grab an M2.5. And the other robot you control the Raspberry Pi. This one is Arduino. Built-in Arduino already. It's part of the system, so you don't need to get. So right, so we have the we have the 3 legs on this side. Okay. So now if we need to pay attention how we're gonna build the other one. So we build a 3. Thinking my instruction meant to go up and down, but I think if I did that, it will make more sense. So here's a companion, but it's a little confused there, both sides. So we need to build the ones that are there. So if we look at it that way, I think much easier if we see this way.
Gosh.
So we get 3.
Amazon is outside again.
So let's get 1. I wonder what the neighborhood thinks about. Okay, 1, 2.
Oh my gosh. They're parking backwards here. When they do that, it's because they have a bunch of stuff. Wow.
All right.
Welcome to MediaBoxEnt on Amazon Live. Follow MediaBoxEnt on Amazon Live. We have open boxes as much as you can believe.
We're going to do 3 of this. All right. Since I know the screws, I have to put it in. It's good today. We're going to think and see if we can finish this part today.
Hey, disappointed. How hard is this kit they were building? It seems like the instructions were a little bit different to the other ones. However, we just had to, I think you had to think a little bit harder and that's it. Because I remember you were complaining about something at the beginning.
Oh, no, the instructions here, there's no picture, there's photo, so it can be a little bit, they don't have a review. They don't have a review, on so because of that. But it's not hard. No.
And what I think about this type of projects is about the idea of building it and learning and sharing, you know.
And I think it's much different if you're going to build it and you're not live streaming.
Yes, it will definitely be faster. Yeah.
You know, or faster, or you take more time. You just go a little bit. You can, you can investigate
like
more.
Like a puzzle, Muru. Like when you build like those puzzles, like we also some pieces. Normally, you don't do it all at once. You do a little bit and then a little bit.
So that's the thing. One thing is building it like the way I do here right now. And another thing is just.
I love this. I do love this type of toys. Absolutely, so I love STEM toys.
We know I need to get 3 of this. So let's get 3 motors here. Okay. So we look in that. If I'm looking at the picture, I'm going to look the ones on this side, and I'm going to go full view, make it more sense for everyone. So I think it's much easier for me to see it this way because I already built. So I need to build the left leg. So we look in this, and this is this way. This has to be this way. So this way, and we see the difference.
Mm-hmm.
We see the difference, right?
It's because one is left and the other one is right.
Right. So that make it much easier to
Oh,
do
the other
this
day,
way.
Muru, the other day I tested your top camera. It's awesome. Like with the zoom, it's super fast.
Oh yeah.
I tried it with the brush. You know, the brush that you press the button and it spins all by itself. It was excellent.
Yep.
And even the brush was going, okay? It was spinning. And it was great.
So now, I think it's much easier to do this way. So since I already built some, now I know by looking at the picture, so exactly know where. So yeah, I think maybe the legs is one. The other one, robot too. The legs takes more time. You gotta make sure you do it right because it's not. It's happened to me already. So you messed up, and then the robot goes nuts. All right. And now we can see here, and here's the hip, right? All right, so we got one. Let's get the other one too. Right there. Much better this way, much faster. Right? Compared to the rest.
You hear it?
What?
Good.
Oh no, I don't know if it because I don't have
Because
my
I was
headphone.
cleaning it and it sneezed. And if you didn't hear it, I'm so happy.
No, I hear it, but I don't know if it went through the microphone. I'm not sure that. I don't have my headphones.
Oh, okay. I see.
Okay. All right. So we got the three things now. So now we get a bill. The one's the other side. So by picking that one out, yep, that's exactly that way you have to do it. So we need to build three of this kind because this is going to go like this. If we're looking over there, we got the two screws here, right? We're looking at the top, two screws there, and that holds here. So since we got that going on right now, let's put that on this side and let's build two more of this. So with that, we need one of this, and that will be the last thing. That's for the ultrasound thing. So this block is done. Okay, so this one is nothing left here. And I know I'm gonna need one of this. And another one. because I gotta build total of 2. No more here. So it should be in the next block, maybe. And another one. Oh, so I need 2 of this. Right, 1 of this. I need 1 of that one. And another one here. And I think with this should be able to complete all the legs. If you build this, if it takes some time, it comes all together. If you go too fast, then you have to do 2 times. Well, go slow and that come out perfect. Got that one there. And when I do this, I know you can say, okay, we can do that and take all that, then you get this crazy. So I will do like the way I do, just take parts after you need it. Now try to clean all that, and then you go crazy and figure out what it is. When it's in the board, it's easy to see it. But I know I need all these parts right now, so I'm taking up. But I don't go beyond, take everything apart, and then I go crazy, figure out what I need. All right, there. There. That's it. For now, I need this. So for this thing, we need 2 of this, 4. This. And we need 1 more. I need those for now. Yeah, because yeah, those are done. So we need 2 more, 2 of this. We're gonna build them the same way. Just like this one. So this is my left side, or the left side of the spire of the hexapod. All right. All right. Yep. And one more motor. And should be exactly the same way. All right. Now we're going to build something like this. All right.
I know those are the little squares, the little boxes that go on the legs. I know that.
Yeah, that's a pain part to build. This is the most pain part.
You know what? I didn't get my helmet yet. They have one that is designed like boot. It's like boot. Nice and quiet Saturday. Welcome to MEDIABOXENT on Amazon Live.
Oh, got to get some screw for this. So what I need? 6. Okay, and one more. All right. Wait, and yes, these crazy nuts. We need 6 of this. All right, let's put that together for now. I think it's much easiest to start on this side. Well, first you got to try to fit the nut. That's the part that is pain. Because it only fits in one way. Oh, I got it faster this time. Okay. All right, stay there, stay there. Yep. this side is much easy. Not much easy, but alright, so I gotta put the finger there and okay. Lost another nut. Alright. I hope that's some extra. Lost two already. Oh, I find it. It's always extra ones, but not many either, you know. Alright, so this we gotta put tape. See, that's the only way I can see.
Yeah, I noticed you were using the tape. That's really convenient, I think.
Well, it's the only way I can do it.
Yeah, but that's not a thing. I think it's really convenient. It makes sense. That's part of organization. Because you're using the tape to mark or using the tape to get the screw in?
To get the nut to stay someplace.
Okay, yeah, that's good. Excellent.
If not, you can't do it, see?
You know what? I think, you know what, Murro? I think even if you had like a small finger, like children, I think you would still need to do something like that. I assume.
Possible.
Yeah.
Alright. Alright, so we got the next one there. Yeah, two. Okay, and I had to build. Oh. Okay, yeah, I have that one there. And that's the next one I gotta build. Yep. Alright. Yep. First you gotta put the nuts before, even before the screw, because not worth to try to put the screw when you can't even. Oh. There. Let's see. Problem with this is this needs to lock there. Alright, we got it there. Alright. We got it there. Okay, let's put now the one in this side, this one. That one kind of can still feel my finger there. So the knot doesn't go the other way around. Oh, it fit. It went through. Yes. And this one there. Oh, I got it. There. Okay. Finally, I got the 3 motors. Should be all the same way. So now I need to get 3 of those things from. So these 3 little things here. You always use this, yeah, all the time. Or another one from another back. Right there. Perfect. And now we need 3 of these things. So those is going to go inside here. We're going to put it right in the center. So if this is reviewer, if this goes this way, you should go this way. Yeah. Okay. Perfect.
MC, welcome back to MEDIABOXENT. MC says, Dario, do you have dreams of the bowl last night? I don't think so,
No.
but you know what? I don't know how to make it work. I would really have to practice before my live stream. That would be a shame. I would be like, yeah, this is this and that is awesome and amazing. And then what? I couldn't make it work. Oh my gosh. So, do you dream about the bowl last night, Murro?
I really don't know what I dreamed about.
You just fell asleep like 1 second.
I can't really remember. I don't know. I dreamed something, but I don't remember now. Oh man. Come on, again. Like there's a mistake. Here.
MC says, you made me laugh so much, Dario, with that. It was
Oh,
crazy
that's
about
right.
the bowl. Oh my god.
Yeah, that was some fun yesterday. All right. And the last one.
The part with the bowl and the jellyfish. Yeah, I know, that was crazy. You know what? We still have the jellyfish here.
So they're next to me right now.
Yeah.
I gotta buy distilled water. Alright, so we followed that picture there. Oh, and I have to get 2.5. Oh, the mic not working or something?
Oh, what's up with the mic? Let me see. Let me double check.
That should be fine. Maybe me.
Yeah, I think so. I'm gonna double check.
Alright, no, just where the. Alright, so we're looking something this way, and this one should go this way. I'm gonna put this same way. Let's press it down. Let's put the screw here. Let's tie this in. And
yeah, works excellent. Oh, wait. I'm so sorry. I just saw the message from CES. He was coming from another message. Does the spider has camera or mic? Yes, it does camera. It has camera and like sonar, right?
This one, no, what?
The spider.
This one?
The other one or this one?
No, this one has a sonar and LEDs. No camera, this one. The big one has a camera and sonar. And LEDs in the back, that's well too. Now this particular one, it has a... This right? Oh, this is wrong. This is wrong. What is that wrong here? Okay, there. So this one has a sonar. So can they figure out if you're gonna touch something? I don't think this one. No, this one has no camera. This particular one now.
Oh, how long does the battery last for the big one?
I really don't know.
Because we played with it like for some time and then I don't know.
I really don't know for how long.
It's a good question because we didn't get to test that.
Well, it's a long time because I was also building it, and you have to build it with the system on. I don't know, maybe an hour or so. Even if you get an hour out of that. And you can see the software will let you know too. The remote, it will let you know how much battery you have left. And what I'm missing here? Okay. Oh, okay. All right. I just got only 2 of those? All right. Wow, okay. All right, we build all the legs, I think. I think that's the most consuming part. I think building the legs is that. Oh. So we're going to review now what we did today. All right. All right, so all right. So what we built today on mechanical parts. So today we built the 6 legs. Took a while. I think that's the most part that consumes a lot of time. So and maybe when a little faster because kind of I already built kind of this thing, so I can figure out now things. But so we have this. I'm gonna kill that picture there for a side in a second. I'm gonna go full view. All right. So we have the 3 legs. That will be the left side. We can see here, the leg and the hip here, and that is what it holds the battery. And we got the 3 ones on the right side, right? The hip again, and then we see how this will grab the spire. And what I know, because if same way. And the same way is the way this one works, but this one requires 3 servos. Here we have only 2. So this one moves this way. See, move this way. This one moves this way, and then the leg this way. Okay, that's the way. This one that should say, and this also can move this way. Okay, building this big one, I figured out that one. But for the question, yes, camera and ultrasonic. This one will allow you to move this way. All right, let's go here. So this way and this way. So how this will work, this will move this way, and that's the way it works, right? It works this way. So this one allow you, move up, and then move left or right, and this will go up and down. So up to here. If we're looking on the full view of that, that's, let me activate that. Yes, and we can see right over here. What is next to that is we're gonna have to put this together, the body. So let's see. We're gonna put it all together, and that's how we're gonna go. Yeah, that after that. And I think that's the main part. When we have that, then we're gonna have to build the head. So this is just the LED part, right? This is the head. That's gonna be where, yeah, this is the LED, the head. I think this is ultrasonic. LEDs. Yeah, so this one they use pictures, so kind of pictures a little bit. The other project was not better, but they have a 3D image, so kind of you figure out things a little bit. So this is what it is. So this is going to move left or right. We got to put the main board. It goes like into the side. Oh, it goes inside there. And then I guess that's the final installation. I will say that. Now this is how we're gonna plug everything in. So D14. So we have to look into the board then and figure out those things out. I'll plug the LEDs, and we put this final somewhere. And that's number 10. Oh, then we got number 12, Servo. We're gonna have to. Oh, it's still Python and computer. That already did. Okay, we're gonna control this with the computer. All right. Okay, I'll set up the Wi-Fi connection. I gotta see how we set up the Wi-Fi. I hope it doesn't require. I'm gonna read that. Yeah, and then Oh, I think it does require a connection, and I think for this I'm gonna have to bring my laptop, because I don't know if I can control it straight to. We got to see that one out. Okay, you need to connect to the module Wi-Fi interface. Okay, so onboard module. Yes, we did that before. Oh, remote configure interface. Then run it. Then connect it. Right, so it creates a hotspot. So we need, right. So we need to connect it through a hotspot. So I'm gonna have to bring my laptop. We can control the keyboard. Okay. I just see that now and control. Okay. Remote control API. That's what. Okay, so we can download. Set up the Wi-Fi connection. Okay, and more config. You need to power the robot. Okay, so we can do it with the. We can do it with the app.
It says mobile application is better on your cell phone.
Yeah. Sometimes, it depends. It's better. Yeah. Some of the things are better, but the computer is what you're gonna run. Yeah, so we can connect the. Okay, error. If an error message appear, okay. Yes, so we connect. We connect with the app. Oh, here, and you control it this way. And that's it. What is called the app? Let's see if I find the app. We can have it for next time. Well, this connects to. Why this thing is connecting? Connecting to a smart light. We get that. All right. Oh, okay. So we can download from the Google Store. We're gonna control both ways. I got it here. So. Let me check. I guess we can control all the. Oh, and the little robot we're gonna build next time. So it's called.
Yeah.
ADPT. Haptic remote control. Okay. Oh, I see it. Yep. Yeah, it's here. All right. Yeah, and this one is the other one I control. This is my test phone. I got so many applications that I load here all the time. Okay, we got it here. All right. So these are the two robots control thing. And let's see the app. Oh, okay. So we gotta put the port number and everything of the board so we can control her. That's simple. Okay. And okay, so not much. I think we can definitely finish next week. This. It's some of the things you did today. It really took some time. I think you can build in a few hours. It took some time because we have if we change it to Windows for the second, and if I go into here, I know maybe it's a little small, so you got to see it. But from 1 to 9, it's all instructions and show you how to understand how the robot works. It gives information how the servos work, how the ultrasound works, how the LED works in RGB code, how the codes and send it through a C and to programming through C using Arduino, how the Arduino works, what kind of Arduino, set up the driver, set up the port, download the Arduino. So from 1 all the way to 9 is all like actually 1 to 8 is, you see, how control the servo, how the data it controls, how to use the lighting, control the mic. So it's pretty good information, because that way you know how the servo works, or how the gyro works, or give you all that. So if you never worked with one of these programs before, or you never did any programming, or never did, no, sure, no, it doesn't require an experience at all. Just know how to put things together. Like if you work on a puzzle, if they put together, blocks, you put blocks together, this is the same thing. So you just follow the instruction, and then give you a little information on electronics and how the things, what data works, right? If you have a little experience, maybe helps a little bit. But besides that, you put it together. And then 9 is the debugging, or set up the servos at 90 degrees. We did that all around. And after we did that, and installation starts here, really. So in reality, 10 and 11 is a full installation of these little robots. How big this thing will be, I think it's going to be something like we see right now. And I think it's still big. It's still a big guy. It's something that big, because if I look in the main chassis, so this is the main thing. That's the main chassis. So if we got one there, one here, one there, and one here, so that big. So it's this big. Okay, that's the guy. How big it is. But it's still big, good size. Sure, you cannot go back with the other one, because we look in the connections are going to be making here. Okay. Well, they make it even bigger, the legs, when the legs expand, right?
Yeah, that's the fun part, Bobby.
Yeah,
you want to make the legs to go all the way up.
Yes, right there. So it's a good, fun project. Now, remember we are here for this type of projects every Saturday. It starts at 1 o'clock in the afternoon, and we create this type of project. So it's a lot of fun. We put robots together and much more. We have all the projects and all the things that can be electronics engineering, right, mechanics, and all these things we want to put together for a learning experience, and it's fun. So every Saturday after 1 for now, that's what we say. And we have more robots. Some of the robots are going to go into the carousel, so you guys have an idea what is coming up. I think I put all the robots there, and maybe that more. We're working on it. And let me switch into that a second so we can review what is coming up. And by the way, like I said before, after 1 o'clock on Saturdays, Monday to Friday, Menina in early mornings. So if you want
right here at MEDIABOXENT.
If you want to meet Menina, she's in the morning, decoration, makeup, tech, home
I'm not
items.
good at makeup. I can
Not
talk
makeup,
about beauty
items.
things.
Yeah, not make items of makeup, whatever. Yeah. And home products and much more. Then I come back with Menina at 5:30 in the afternoon. It's always Eastern time. We come back at 5:30 in the afternoon, and we set, again, tech, audio, TV, computer, laptops, and how to build your own computer, home item, smart devices, camera, lighting, podcast, microphone. We cover it all. Everything. And then we resume it back again. I mean, in the mornings, on Saturday mornings, I come back with run the kitchens where we do keto and low carb recipes. And maybe next Saturday we'll come back again. Took a little break this Saturday, and we come back. So it's pretty much we covered almost the whole catalog, right over here on Amazon with everything.
Yes, absolutely. Right here on MEDIABOXENT.
I'm gonna go back in a little bit on my And here I'm gonna switch right there. So this is the one we're building right now. We continue next week. Then we finish building this one today. Although I show you how that worked today. Now, what is coming up?
Hello, Mallory. Welcome to MediaBoxEnt on Amazon Live. Follow MediaBoxEnt on Amazon Live.
So another one coming up. Maybe we start next week, right? So we have this robot. This is a big one. All right, we can make 2 out of that.
Oh, yeah.
We can build 2 out of that. So this one is coming up. It's coming up next week. This has all metal cases and everything. All right. So this will be a little bit.
To the other one, the blue one. I had to get into that.
Yes. This one we already built it. All right. So we built our robots here.
Yeah.
This one's a lot of fun.
I think when you go to your warehouse, we had to make like a fun thing to make them all like dance around.
We're looking into this. Not a promise this one yet, but we're looking at something like this.
Yeah, that's what I was talking about.
Yeah, we're looking something like this. Not set yet for that. And what else we have? We did build this one already. We did build this one already as well too.
Oh yeah, the doggy.
And
I think we can use the new device that we got today for the dust on the computer to clean the robots.
All the robots are possible to come up, and then we have 2 more. Hold on. One we receive it today. We just put it away. Hold on. Can you paste it in the 2 little robots?
Oh yeah. Hold on. Let me
paste it there. We built this card. We need to fix it. No, something like this. We need to get that going.
We have that. Oh, I can get you one more of those if you want to.
Yeah, we get that going.
Okay, let me get the link for that.
So we did put a lot of stuff. So, and let's review the 2 more robots. So we have to work on more robots.
Okay, this one on the chat is arriving on Tuesday, according to Amazon, okay? And I'm going to put the other one too that was supposed to arrive on Tuesday, but arrived today. And this is the one.
Yeah, this is a small one. This is like a fun one. This is more for kids. Maybe they want to put together this little guy, right? But this is another robot that we're going to be building, not next week, but 2 weeks, about 2 weeks from now, I think. We think it's something that way, all right? And then the one we just got today. Let me know if you put in the chat.
Yeah, Morro, it's in the chat.
Oh, it's in the chat, the other one? And then we just received today that we did an open box for that for you guys. I'll show a little bit. I'll show you. I did an open box there. And there's another one coming up. This one also has control and no Raspberry Pi required this. Think it now.
Oh no, from the time you had the remote control, I don't think so.
No,
I don't think so.
No, this one control. Yeah, so this one no Raspberry Pi required for this one. Okay, so this one is like a whole board already printed and built. So I think this will be much an easy project to build. So let's see. All right, so we have more. All right. All right. So I think that's good for tonight. We had a lot of fun. All right, Menina.
Victor Cruz, welcome to MediaBoxEnt on Amazon Live. Make one that flies and cooks. That's a good one, Victor.
Yeah. Well, who knows? I'm gonna make that human side one.
All of MediaBoxEnt on Amazon, Victor. Yeah, that'll be really cool. Like, forget about it.
Yeah.
The flies cooks and clean. I cleaned the floor today. It looks beautiful. I'm so happy.
Yeah, so we're gonna build one. Yeah, we're gonna build one that flies, everything. Who knows? I mean, there's so many things that they are available here in Amazon to build.
Yes.
And we discover as we go, and I'm sure we trying to bring more robots. So now we have 4 more robots to build. Let me see, 3 more.
I don't know.
4 more. Right, 4 or 3 more to build. We'll pass this one. So this one guy, the one you see right in the picture, we're gonna complete this next Saturday. Remember, 1 o'clock in afternoon, right? If it's something changed, I will let you know, guys. But we'll complete this little guy here. It's still pretty big. We're gonna complete this coming up Saturday. All right. So guys, some weekend Saturday, so enjoy it, have fun,
and we're gonna see you next time, right?
And I'll see you next time.
Seriously, bye for now. You're gonna
Bye.
put the sign?
No, because it's just
it doesn't
tomorrow.
say tomorrow.
Yeah,
It makes a difference.
Yeah.
Okay.
All right.
Bye.
Bye.
I'm gonna press it. Bye.